Why is that scrolling away? Oh, it still has fade turned on. Fade. I don't know, off? 0? Probably off. Can you hear me? Is this working? Okay, let's once again fix the configure video brightness. I don't know why it doesn't retain my settings here. Okay, I just want to see what that would look like. We'll set it up properly some other time. I want to put some. That's set at the darkest setting, and it's still too bright. So I either need to add just more lights overall, so that highlight is less visible, or I need to put something into putting like a gel to darken it. But I think it does look nice. I mean, it's like a Casey ripoff, but it does look nice to have a little pop of color. But I do wish that it would remember that this is what I've set my camera to instead of making me reset it every time. Okay. Do you think the chat window, should I make the text larger, or is it okay at that size? When we switch to having the screen up, it's going to be actually a different text window too for that. So, a different chat window. Because it's trivial for you to bump it larger if it should be. Okay, and now let's go ahead and switch to the other one just so that I can am I forgetting anything? No. Okay, so now I can actually see this preview and I can drag this up. Should I have, maybe I should have two. One is stream info and one is like FAQ or something. But that text spacing is a little tight, maybe. Oops, sorry, bumping the mic. All right. I guess maybe if I put the chat overlay on the left thing is the least important thing to see, the way I have my workspace set up. Because I don't normally close this. I do leave this open. So maybe putting it on the left would actually be fine. Except that I prefer it to be narrower like that, and that the chat was a lot wider than that. Yeah, that's pretty wide. Although why does the chat not actually show in the other one? Yeah, that's just too goofy. Okay. So I think that's an okay compromise for the displaying chat and still leaving me this nice panel. Okay, prefix. Chat with nothing to. I see it. Yeah, but most streamers are not displaying a big IDE and multiple text windows and etc., right? What do most programming streamers do? Because I want space to have an FAQ, to do, plan, etc. I haven't been updating this text file because there wasn't space because I had the chat overlay, the chat window down here. So there wasn't really room for me to put much here. But now I can start filling this out. Because what I used to do on OBBG, I actually had a text file that was a list of what we had done recently. So I think what I'll do is I'll have two text windows down here. One is stream info, and what have we been doing. But for now, I'll just have the one. Yeah, the chat is on the screen so that the YouTube archive, the chat remains visible. Okay. So I gotta move the mic further away. It's distracting me. So we'll see if I need to turn it up when I move it away. Okay. I think it's fine. Might be a little quiet now. A little quiet now. A little quiet now. A little quiet now. Testing 1, 2, 3. Okay. Yeah, but like I said, I want two different stream infos, so. Okay, yeah, if I start clipping, let me know. All right, so the only thing I did since yesterday's stream is I copy-pasted this file from another project that's just some of the busy work of setting up buffers and textures. I wanted to correct myself. One thing that I said yesterday, I was talking about this voxel meshing strategy with the pairs of face quads, and I was saying if you do a proper mesh, you just actually really build a regular mesh, then you have the opportunity to share vertices, right? Because you're making an indexed vertex buffer, and so when you make a normal mesh, normally each vertex gets shared, because you have a continuous surface with a bunch of vertices on it, and it's the same vertex, a bunch of triangles around it. But typically, when you're doing textured voxels blocks like Minecraft, each vertex needs to get texture coordinates and maybe a lighting value describing it. And so it doesn't matter what the next one over is because it's not going to share that data. Now, it turns out you could actually share that data and try to get those vertices to be shared more, but I don't think most people do, so I don't think we're missing anything by not doing it here. You get the sharing from using a quad instead of two triangles that are 6 vertices, you have 4 vertices for the quad, which could effectively be a little index buffer. I'm using OpenGL, so I can just use quads, so I don't even have to have 6 vertices with two triangles, although I could do it that way if I want to. Yeah, most streamers don't have the IDEs file tree unlocked. Yeah, but I mean, it's also just like how much space do you want for your text and stuff. Like also, yeah, I mean, it's 16 by 9. At least it's one of the sucky things of, I guess it's 16 by 9. It gives you more horizontal space, so it's easier to justify putting the chat on one side. But I use the full compiler, yeah, from VC6. Yeah, having the captions in chat just doesn't sound good to me because you want to be able to sort of see them all at once, look back and forth at people without having to scan back and forth in the video. Unless they can do like big, long subtitles that emulate, like the subtitles has the last 4 comments at all times, but I assume that would be too messy. And it's also just better that they don't have to turn them on because they don't know that they exist, and they don't have to. We control exactly what they're hiding or whatever. I was thinking it would be better to have those old messages fade out, but I think maybe for the sake of archiving, it shouldn't, or I should have them fade out over a longer time. Oops, typing the wrong keyboard. Okay. So I just added this file. This was all code that I had for something else. That's the only thing I changed. And then that whole thing about the vertex sharing, the index sharing of vertices. And I think that's it. Okay. So now I can start writing into stream info. C Twitch below video. Recent history. Previous stream experience. Why did I stream before? Why now? Okay. So, okay, so we wrote this yesterday, our vertex shader that does the mesh pairs. And then we have our plan. Yeah, so our plan CPU supplied 56 by 26 by 26 grid of 32-bit values, yeah. So now we have the command list format. We can go 0 to 255. Yeah, so it's x0, xlen. X0. Let's hypothetically limit it to 7. And we'll see how the math works out. 7ylen. 12 z0. 12 zlen. So I can't do x0 to x1 with an exclusive because if 8 bits, the voxels can go 0 to 255, and so like you'd want to say 0 to 256 as the exclusive endpoint. So I could either do inclusive endpoints or I can do lengths. The lengths will still limit it to at most 255. So these are lengths plus 1, or that means you're storing -1 in it. Which maybe means I should just go ahead and do inclusive endpoints. Maybe that's just going to be cleaner. I don't like to mix inclusive and exclusive. Oh, but this lets me do shorter, right? That was the whole point. Was the other reason is that then I have to always use the full thing. So we can say 10. And then we have 30-bit texture IDs for the interiors of the slab. So 2-bit type. So slab, which is a rectangular, solid rectangular parallelepiped. And 30 bits of texture IDs for the exterior. This is a change from yesterday. Yeah, so this is just describing a big, like, cube, stretched cube. So it's three-dimensional solid. So that's a CSG subtract. Okay, so now let's add this up. I could probably just do it in my head faster, actually. So 60, 70, 82, 90, 98, 100, 114. 114, so that's approaching 128 bits, which is 32 bits times 4. In which case we can just say that that's 32 and that's 32. Because we want to make them, pack them into 32-bit values. So 8 and 8 is 16 and 14. So these at least go up by 1. Oh, maybe these do that too. So let's put those back to full size and see where we get. That's a 32. That is 24, 26. So we have a 32-bit value. That's 24, 26, so 6 padding. And then we'll just, it's that same thing for this. AMP, I couldn't tell you because I'm not a person known for shipping games. I'm a person known for dallying with making games and making game engines. So what are people's opinions? Should I just make a really narrow chat window that's going to suck for when people type long things and put it on the left? Or should I stick with what I've got here? I'm not reading it. This is just for the YouTube archive. I have a separate window that I'm reading. It's funny because I'm doing this this thing I showed yesterday where I keep the stream hidden under the camera so that because I don't see that camera display, that's something OBS is doing. So right now you're looking at what I actually see, and so that is showing me the stream, so that which is just there to so I'll notice if I forget to change scenes. But the problem is that the scene that happens, if you imagine how can I say this? Like when I switch to the other mode, if you imagine what my desktop might look like underneath this, it shows a picture of me in the top right corner and then my desktop. So what I see looking at my desktop is what I intend the streaming setup to look like. It's what you normally see. So if I'm in the scene that's just me filling the thing, then on my desktop I see what looks like what you guys normally see in the stream. Which means I see that and forget that means I'm on the wrong scene. So it's just totally not working. Yeah, but the streamer deck isn't going to help me remember that. For that, I'm just talking about me remembering to change scenes, and I don't think the streamer deck's going to help for that, unless just seeing it on my desktop reminds me. Yeah, but would I notice? Would I remember the connection? The C compiler was something I was working on for Red, and then I moved on to other projects, and then we got acquired by Epic, and so it died. I gave more detail and more interesting answers on a previous stream, but I'm not going to repeat it. Maybe I'll repeat it in a couple of weeks or something. I'm not going to say it every time. Okay, so I'm putting off doing the boring work, so I'm designing the command list format here. Are there other things? What other things could you do? Oh, yeah, I remember what I want to do. So instead of 6 bits of padding, let's have 4 bits of padding and have 2 bits of type of texture, 1 bit texture ID indirection, texture interior ID indirection, 1 bit texture exterior ID indirection. So the idea is, like, right now you can place a big slab and it's the same texture on every voxel, except I add this interior exterior thing. So you can make it so the exterior is what you'll see from the slab, but if you cut a hole into it, you'll see the interior textures. Yeah, a disappointing thing about OBS is that you can't view one scene while displaying another scene, so to tweak the thing. I guess they said maybe the studio mode can do it, but I didn't want to try touching studio mode. I remember you tweeting about using Python. Did you end up incorporating Python into your workflow? No, I just was using Python. Well, very early I was using Python to experiment with AI, but then I stopped working with AI. But I still use Python occasionally if, like, I need to interact with an API. Trying to think of what else I use it. Some very rare occasional stuff that it feels like I could get it done faster with Python than with SDB. Now that I know Python enough, maybe to write it a little quickly. Yeah, because as soon as in C you need you want to do like HTTPS or anything like that, you're screwed because you need this whole crypto infrastructure. And then I'm screwed in VC6 at least because I can't just pull in a DLL that works with it. Transitions just make it look nice when you switch between scenes, but it doesn't let you preview the scene that you're going to switch to. Okay, anyway, so what else? So yeah, so what other things could you do? So yeah, I was saying that this thing lets you make a big slab of voxels. This will be clear when we actually start putting it in the engine. But they're all the exact same textures. They're all the same block type. We don't have block types, but that's conceptually. And so the idea is, like, maybe you want to have a pattern on the building facade. And rather than have to construct that by drawing lots of separate little things, we'll just have a texture, and the texels inside this texture are themselves texture IDs. So you have a map of where you want different texture IDs. And that is going to be somehow encoded in 32 bits, or maybe more. Maybe I'll make that a separate larger thing. I think what I want to do is because we know we're going to process in columns, I think what we want to do is store columns of texture IDs in a relatively simple way that, again, will be 32 bits because that's how we're processing the command packets, once they're reduced down to being for a single column, they're still 32-bit. So that would be a 32-bit index into a map of texture IDs that you then just offset as you sample up. Yeah, explicitly said HTTPS. But even just HTTP, yeah, I've thought about doing an STB crypto and STB HTTP. Well, actually, you can use Windows HTTP from VC6. Maybe you can use Windows HTTPS from VC6, but the actual thing you run into is the APIs that have their own crypto stuff. Like there's like auth2, that kind of stuff. That was actually the barrier, now that I think about it. So anyway, or texture pointer. So probably what you end up having is let me not just describe it. Let's sketch it out. So what we want to do is we want to draw, like, say, a wall that's 10 units along. Well, it's 50 units along the X, 1 unit along the Y because it's a wall, and it's 100 units tall because it's a tall building. And what we want to do is have a column of texture IDs stored in memory. So, it would look, like this, say, to have a simple stripe pattern. If we use that column everywhere, then you would get a stripe with the one texture every fourth block. So the Z-axis stores sequential 32-bit texture IDs. And by 32-bit texture IDs, I mean 6 packed sequential 30-bit 6x5 packed texture IDs in memory. Then we have an XY texture that is an array of those pointers. But we want to be able to use this on different slab sizes, and we want to have multiples of these. So you need, like, naively, you need like a pointer to where the data starts and how big is the x-axis for it and the y-axis. So what we do is we make one big grid. We make an atlas of these super textures. So we have an XY atlas of pointers. So say it's 1K by 1K. And so it's this big grid. And so, like, if we want to have we might actually special case the stripe thing, but if you want to have this same texture set of textures appearing in along a wall, all the same for the whole columns, what we do is we want to say, like, okay, well, the biggest thing we'll support is 100 by 100. Well, actually, no, we'll only do it support for walls. So we pick one row of the XY atlas and store like a 512, well, it's 256 is the max. So we store like a 256 by 1 set of these pointers to columns, but they'll all point to the exact same column data. If any of that makes sense, great. If it doesn't make sense, well, eventually we'll program it and hopefully it'll make sense. Okay, is there anything else I could do besides the slab. Oh, and so then the point of this, the point that I was getting at is now, instead of this texture ID, texture pointer being complicated, it's just a texture XY. So, okay, let's do this. Direct. Indirect. 16. It's the X is Atlas texture in interior texture block interior texture Atlas X origin 16 block interior texture Atlas Y origin. So it takes up the same amount of space either way, but and now you can just use offsetting to get to it. I have not done any serious metaprogramming in C. OAuth. No, I said auth, and I meant OAuth, yeah. Like there's something like OAuth, or maybe it was the first OAuth, where it's just like some hashes or something, but you still need some crypto primitives to do it. But yeah, there are some where it's like a whole crazy interaction. There's another 32-bit in. There's the interior and the exterior. And it's... so what else? What other kind of drawing commands could you have? We could have place 3D texture instantiate model from 3D texture. So that's going to need an origin. So it needs an origin for where it starts. Ooh. This needs... Oh, we can subsume it. Okay. Oh, it'll still need actually the len. It needs all these. And then we'll have to figure out what's the strategy that lets us place these that's temporally consistent with the CSG. Maybe you can only place these after everything else so that we can avoid the complicated unpacking problem. Didn't we only have 2 bits for commands? We only have 2 bits for commands. Yes. I mean, we can always change that if we need it, but so I only can have 4 commands. I just wanted to see if I can think of more than 2 commands. That's why these 2-bit type fields have the name there, because the 2 bits are implying the name. So then it needs, it's going to be, we will pack all of them into one big 3D texture in that same way for the same simplicity. How big can a 3D texture be? 1K by 1K by 1K would be a gigabyte. And if it was 32-bit values, it would be 4 gigabytes, so that's way too big. I wonder if we want to have, like, to actually use the same style of encoding with a bit field. With a dense bit field and a sparse text string. That might make sense. Yeah, this is just the command list for building voxels from some kind of description that is used to construct the mesh. So a command to do debug draw info would be somewhere else in the system, not this particular thing. Yeah, knowing how we're going to mesh it. Really implies a different data format. So we'll come back to it, because I don't know that I'll even use that for this. There's a pitch here that there's two possible ways to drive it, one from the CPU and one from the GPU. The CPU is generating arbitrary infinite procedural detail, and the GPU is working from what's in GPU memory, which is some fixed map that you're still remeshing on the fly as you move around. And so I think it makes more sense that the GPU one might use these baked instances so that the map can be more compact rather than trying to describe everything uniquely. The texels in the 3D texture would each represent a voxel. So I don't know how it would get constructed. Like, maybe you would store it, maybe it would be offline, you would load it in, but maybe you would at startup construct the models from procedural descriptions in the same, like if we already have code to build buildings procedurally, then there might just be a fixed set of buildings that you build into this 3D texture at startup, something like that. But conceptually, yes, it's a model that you load in and then can instantiate. Okay, probably time to stop putting that off. All right, we did the vertex.js, and now we need to build the test vertex buffer and upload it and draw it. Gotta stop tabbing through. Okay. So, what did I add to create texture? Oh, whether to map or not. Yes, I did write a tiny bit of code to fix this. Oh, what was load shader file doing? Which project did I take this from? It was from Voxel? No. Maybe. What's it called? Load shader file. Okay, so it wasn't for that. It was from... Yeah, okay. Oh, okay. Load shader file is doing this silly thing. So yeah, I just need to SB file it. Oops. MC2. SB file. Did I end up doing programming offline? No, I just copied this one file from another project. So I am getting a bunch of free code without writing it, but when we use it, I'll mention what's going on with it. Okay, so there's that. So if I run that, it does run and doesn't report any errors. I believe create program will show errors. I think it opens a message box on error. Yeah, okay. It exits if it fails to compile. Opens up a message box with an error message and exits. Yes, I have AP draw size defined twice. I talked about that in the last stream. Okay, so we need to create a vertex buffer. So we're going to call init buffer system. And then we're going to call create shader storage. We'll make it 4 megabytes just as a something. So this is vbuff. Oh, let's just draw something immediate mode and make sure we have something drawing. So let's do the classic GL lines, GL color 100, GL vertex 100, vertex 000. Init buffer system. Base is calling STP. Oh, SB platform implementation. Guess it should do that automatically. Yes, color 3F, 3F, 3F. Okay, that still won't be visible because we're not setting up our camera yet. So let's go in here and see where we set up the camera. Oh, it's part of a render scene. Why do I do that twice? That's weird. Here it is. What's the GL translate? Why does it never translate the camera? Oh, because it's position reversed, maybe? No, it's projection reversed. They're in X, Y, and Z. Oh, there it is eventually. Okay. I think that's the only part that I don't know off the top of my head, so let's do that. Okay, so let's go right here and say geomatrix mode, geo projection, geo load identity. glue projection, glue something. GL matrix mode, GL model view. This is negative extra FPS input, mouse look degrees x. GL translate XYZ. Oh, I guess we should do that after we move the camera, which is right here. Glue project. Glue. No, oh, that's gone. Project. Oh, did I get rid of glue projection? I thought I had a thing for that. The default camera is like orthogonal 2D or something. And one of the things we, like, yeah, we know we're drawing black. We know that stuff is getting drawn somewhere. Like, what we want to do is to use it to debug the camera. So we have to actually get the camera in. Glue. How do I do this? Big Chips uses projection reversed. Box call might still use it. Set camera matrix. No, it's doing something trickier. What's something that I do where I might do it the naive way? Not sure why Big Chips doesn't do it. What about oh, I do it in a different order for that. That's interesting. Glue perspective. Oh, it's perspective, not projection. Of course. SimC2. What's our ratio? AP to draw size. It was there for a moment until I moved my mouse. But it's flickering weirdly. Oh, it spins incredibly fast. Still spins incredibly like that, so I'm doing something wrong somewhere. And I don't know why it's flickering. Yeah, actually we want to do this if we were drawing these lines as debug stuff. Oh, I might be sitting right on it. I might be, I'm at the origin and it's at the origin. Oh, no, it's not. Z is 10. Okay, so it's a negative 10. Okay. No, as soon as I move, it goes away. So something is horribly wrong. This is welcome to the standard debug the black screen problem. Like, I've cut and pasted almost all of this code, so I don't know how it could be wrong. Oh, my keyboard is just some cheap thing with squishy keys. It's an old Dell. It's not Z fighting because nothing else is being drawn. My move speed probably is super high. Oh, yeah. That's supposed to be commented out. But also, at the scale I'm operating right now. So that might help this movement. Why does it start rotating when I know. There we go. That'll fix it. Except now I can't see it by default, but... But at least that'll fix the weirdness. Why can't I see it by default? Nothing should change by default, right? Well, I guess the loaded entity changed something. So let's set Z to negative 10. Nope, nothing. Let's draw a big ground plane. Vertex 2F, 3F, negative 5,000, negative 5,000, disable, base is already disabled. Okay. Huge plane goes out past the far clipping plane, so you can't see the corners of it. Let's bring that in, and we should see corners now. Okay, so the rotation feels weird, and I think that's this. Nope, it's still doing something weird. I'm pretty sure that is right. X, Y, Z. So you want to rotate around X for pitch and Z. X, Y, Z. You want to rotate X for pitch. Ah. Let's move this down below the other thing so we don't overdraw it. The axis display. Yeah, that interpolation isn't good because it's the default thing. I just wanted to see that there was something there. Yeah, I mean the translate, like, or maybe the translate needs to be negated and stuff like that. But let's allow the rotation. Oh, I forgot I turned this down. Wait. So let's allow mouse look to spin really far so that we can look behind us. Okay. Okay, that's way too much. So we'll do over 4, but we'll scale up X to make sure we can turn far on X. I tried running GDebugger, and it died on my compute shader voxel column stuff, and it does failed on the very first link. It claimed I wasn't setting the compute shader workgroup size, even though I was. Okay, so I'm seeing all the 4 of the corners. I guess we bring it in further. Maybe it's just too far away. Yep, I see a corner now. So I'm seeing all 4 of the corners, and I'm not seeing the... I'm not seeing this thing. Am I doing something wrong there? Maybe I'm above or below it. Oh, yep. Okay, why is one axis really long? Is that something I typed in? No. Why is the red axis so long? Is that because my camera is like has a really weird field of view? Yeah, it does. Why am I not moving the direction I'm pointing? So this movement direction is wrong, even though it came from that stuff. Maybe it's because the X and Y are revert, like, probably. Maybe it's this plus 90 is wrong. Z is only affected by dy. So dy is zs and zc. I don't know. Oh, right, I want to change the field of view. So this must just have a weird field of view. Did I do this wrong when I computed this? Because I replaced that from the old code. Oh, well, that's code that I may itself have a wrong field of view. It's x over y. Oh, it's x over y. So that'll help the field of view a little bit. And then maybe make it 80. Yeah, okay, that looks more sane. This is moving along entirely wrong axis. which means ZC was wrong. So maybe switching X and Y was wrong. Oh, that's in the wrong direction, so let's remove the plus 90. So I don't know why that was being done in that thing. That's weird. Okay, I think this is right. Nope, it ain't right, because we're not moving towards it. Oh, maybe it's X that needs to be offset? In the other direction? Which could also just be like swapping. It's also just like swapping around which things take sines and which things take cosines there, which is probably the right way to fix it. No, this is still moving in the opposite direction. Vertically it's correct, but on the XY plane, it's 180 reversed. Well, roughly 180 reversed. No, it's sideways right now. Wait. That one's correct. That one's moving in the correct direction. So it's like we're ignoring the x-axis rotation? Oh, because it's ×4 down here, so it has to be ×4 up here. Okay, so let's just get rid of the ×4. There we go. We're always moving. Yes. Okay. Hooray. We finally got that working. So, we created our shader storage, and now we want to create some voxels. So the voxel format, oh, it's in the file. Is this is the voxel format. So we make voxel face pair 32 data 2 comma. So data of 0 equals x or y shift 8 or z shift left 16. Or base pair shift left 30. Data 1 equals text 1 or text 2 shift 8. So then we want to make a little buffer, contain some voxels. And it's 32. 64. 382. I'll need to make a voxel. say voxel face pair data 0 x y z 0 type. Make a voxel at let's say 1 1 1 buffer of 0 at 1 1 1. Make a voxel at 4 1 1 and make a voxel at 4 1 2. Okay, and then update buffer. Update buffer vbuff. Starting at 0. The length is 3 times size of buffer of 0. And the data is buffer. Then we say let's check that I did the face one incorrectly. We just hit an error. Which is message. Oh, it's up there. Why does it have that hit? It was visible, so that's good. We made a shader storage buffer, right? Yeah, that's just all hidden inside this. Create shader storage buffer. There's no hits. Oh, it's the staging buffer. No, that's just dynamic storage bit. Which buffer? Okay. Well, that's why we breakpoint. Oh, it didn't do it this time. Oh, because I disabled the breakpoint. So what's the call? Okay, so, right, we're staging it by uploading to a buffer that we're going to use for copy read. So we tell GL that, and GL tells us when we try to CPU update a buffer that we said we're doing for copy read. Buffer object 1, why is it bound to GL texture buffer? I don't know, but yes, it is, the type is copy read. Usage is dynamic draw. We'll use video memory as the source for buffer operations. Okay, no, that is just correct. That's just not a useful debug message. Okay, so we just don't care about that message. Okay, so maybe we've uploaded the vertex buffer successfully at that point, since we didn't get any errors. Yeah. Like I have a debug context set up, so I should get error notifications without doing geoget errors. So those should be unnecessary. And then, but let's just leave them in just in case there was some reason for it. Okay, so now we've got a vertex buffer and we want to draw from it. GL program. What's it called? GeoProgram ARB? GeoProgram? GeoUse program. Voxel program. There's uniforms that we have to set. And we have to bind the voxel mesh buffer. Oh yeah, here's the uniforms. So we have to initialize all this stuff, which I don't remember how to do. Is the binding the uniform location? Like, or the chat window is different because I want this space for not chat window. The old thing was just a temporary solution until I got something else up. You don't get the chat window here. I could put the chat window here, but it's really narrow. And as this program gets bigger, there will be more files on the left, and that'll start to get occupied. I mean, remember, the chat window is only for the YouTube archive. I could even make the text too small to read because the YouTube archive is uploaded at a higher resolution. I don't remember how any of this works. I'll have to look at one of the other programs. Let's use Voxel. Does it have layout bindings? There's layout bindings for uniforms. Oh, here we go. Ground shadow. So let's go look for ground shadow. Ground shadow. Is that binding equals 1? Yeah, okay, so that's how you do it. Not sure what that's. Is that implied by bind buffer base? Is that why it's doing that? Or is it just coincidental? Well, it keeps doing it. So this gets 0 vbuff. Oh, I shouldn't use. Oh yeah, no, this 0 is a binding number. This 0 is a buffer number. Okay, so that does this. And then we have to do our uniforms, which we do in this very clumsy way. You shouldn't do it on the fly like this, but it never was worth fixing. So we want to get voxel here, camera pause. And I guess I could use bindings for these two, but 3FV, 3F. I don't know if I have 3F. Uniform. I might only have V. I do have 3F. Okay. And then we have voxel shader, chunk origin pause. Is that supposed to be a UVec? I have a feeling that's supposed to be a UVec. Chunk origin pause. Yeah, because we're adding it to UVec and throwing it a UVec. So yeah, this should be a UVec. I mean, you could be allowed to position them arbitrarily anywhere, but to I 0, 0. What do they call it? Voxel shader? Voxel shader. Oh, which is what I used to for those other ones. Of course, it's got to be P. Okay. Voxel shader does not refer to something generated by OpenGL. That seems unlikely. Let's make sure we're in synchronous mode, which we don't normally do because it's slow. How is this? We probably never called it. We probably never compiled the shader. Because I never got any errors. There's a hot load for those shaders, but let's do it here. So yeah, now we'll get a shader compile error probably, because this was probably the first time compiling that shader. Yep. Voxel mesh. Oh wait. A token voxel mesh buffer. So I didn't get the syntax for this right, for this. I thought I copied that from here to make sure I got the syntax right. Looks the same to me. I don't do scopes inside my begin ends unless I need them, because they take up extra lines of code. What am I missing? Let's bring the error up again. Compile error for vertex shader. Syntax error, unexpected error, expecting reserved word or reserved word in or reserved. Maybe it's because I'm in a different mode, because I'm in version 420 compatibility. Isn't standard 430 what the other one said? Or does that maybe require that I be in version 430? Yeah, I bet it does. So the error message is just being wrong. Yeah, the error message was just being wrong. And then where was the cast? Right here. Oh, I haven't actually drawn anything with the use program. So we use program, we do that, then we say we need indices. We need to store indices. Or can we just upload indices? Is there a call to upload an index? There must be a call. Can you specify indices in the between begin and end? GL index. That's for colors. OpenGL immediate mode array index. I've never tried doing indices. No, it's only if you start having arrays. So we do have to, I guess we can do the array locally. Like there is some support for if you set the buffer is 0, then it does a local array. So well, okay, let's just, how many voxels did we have? We had 3 voxels times 3 faces times 4 indices. I think that's the name of it. Dang it. Divide by size of. Oh. Okay. And then how do we issue this call? GL draw elements. GL quads. Times 3. Assign short. Indices. Aha! We got one pair. I guess cull face isn't set at this moment, which is fine. So let's see. Either they're all drawing in the same spot, or we're only getting one pair. Aha, we got a different pair if we advanced it. So it's like we're only getting one pair from each voxel, and there's only 2 voxels. So we're like doing some math wrong somewhere. Oh, this is the number of indices, not the number of primitives, maybe. Is that right? Is that the number of indices, not the number of primitives? Yeah, it's getting close. Let's bottom and top is wrong, maybe. The up down is wrong. Although if we have cull face off, disable cull face. So if cull face is disabled, if it draws on the wrong side, it should still be visible. So I don't think it makes sense to flip this test. Like, do we encode the wrong? Negative Z is at Z0, positive Z is at Z1. Yeah, that makes sense. So if Z is larger than the voxel pos, let's do the center of the voxel. The reason we were seeing a pair, no, that's not right. I don't know why we were seeing a pair. Oh, yeah. I don't know why we see the backside of this. We shouldn't, because there should only be one quad for that. So that's like the even if we drew that pair twice, it should only draw the thing on the front. So either we've encoded the vertices wrong, so it's instead of drawing the top face, it's drawing the back, that quote unquote back face, or what else could go wrong? Or we're offset in our index array incorrectly, but I don't see how that could happen. Okay, let's debug it this way. Let us draw one face at a time. And then commit that. So now if we say, what was the key? H, okay. H. Yeah, that already doesn't make sense. H. Okay, so there were three, and then we jumped over to the other guy. Yeah, so the up and down face is being decoded wrong somehow. And it's showing up on the backside. Did we get this backwards? Is this supposed to be plus 6 times? Which face is 0 to 5? We encoded these as nibbles based horizontally. So the rows are vertices within the quad. The columns are which face, and it's row major. Yeah, so that's correct. So why do we get the back thing? Did I just screw up the magic numbers somehow? Okay, well, let's say... So if this computation were wrong... Oh, yep, there you go. Yep, okay. Okay, so it's drawing the back side of the Z. Like the Z is not right. Now that could be because like we're not saying the camera position correctly. Let's maybe make the background color different so that we can see those. So we're not computing that stuff correctly. The camera position decisions. So it's like you're using the wrong axes, it looks like. Maybe we do turn the base back on. But the face pairs were in... Okay, but then we packed them in this order. Okay. What would that be? Camera pause, voxel pause, camera pause, voxel pause, camera pause, voxel pause. There's no reason those axes would be swapped in these different modes, because we translate X, Y, and Z. We pass in X, Y, Z. And is that where we actually translate them to? Where do we actually put the position? Voxel pause plus vert offset, which is either 0 or 1. And we were comparing against voxel pause plus 0.5. That seems right. What would do this? What could cause that behavior? I guess I gotta go back to looking at an individual one and seeing how it behaves. So that's space times 4. There are switches, but look, we're not crossing any axes. We're not crossing the x-axis. We're not crossing the y-axis. We're not crossing the z-axis relative to where that is. Is there a keyboard key to move up and down? Oh, minus and plus. So it's not even. Is something getting rotated before we do the comparison? No, because we're just doing it in world space. Chunk origin pos.x. Why is that transitioning so far away from the thing? It's like something's offset. But I don't see anything offset. All right, this is and 1, so it's only plus or minus 1. Or plus 1 or plus 0. What could do that? I guess I play with it some more, see if it makes my brain trigger anything. Okay, is it actually happening along that axis? Is it actually happening along that axis? Is it happening along the diagonal? Okay, I need to be able to move sideways. Oh, I can with A and D. No, I can't. They don't work. Oh, because that's dx. So what do you multiply? Let's just do this. See if that does something useful. Oops, let's see. Okay. Okay, so the transition happens there. Now, if we move further back, yeah, transition happens at the same point. So the transition is just spaced off by a little bit. So now let's pick that one and see where that one transitions. Yeah, it's transitioning a little bit off. Is it relative to the origin? No. Maybe, because of the plus 0.5, maybe it's relative to the origin? Yeah, Sherlock said one axis going negative to positive. Which would imply it's like that voxel pos is 0. But voxel pos is not 0 because maybe the translate ought to be negative XY, negative Y and Z, although that will no longer work because everything else has been tuned to it. And so effectively, the camera pause is now negative X, negative Y, negative Z. Yep. Yep. Okay. So we'll propagate that negation back all the way through later. But for now, put that back to I. 2 times 3 times 4. Looks like this works. So now we need to load up a texture so that we can actually see it in a sensible way. Oh, now let's do face culling. No, let's get the texture in and then we'll do face culling. Yeah, I don't want to try to propagate the color through. We'll just, because the texture will show what I want to show. See, this is why I missed those toolbars. So what texture should we use? Let's maybe use the, I don't know what format those are in. Art. Texture candidates. Okay, these are all in JPEGs. So here, let's just copy these over. Maker games CMC2 data textures. Okay. CMC2 data textures. Because we're going to want to test having multiple textures very soon, because it is already set up to do the texture array stuff. So then we go to main, and so SDB platform has a load texture. I don't know what it's called. SDB load texture from image file. Texture from image file. Not auto-completing. So we're already in data, so it's textures slash, I don't know what a good texture is. Let's do that. Maybe that. Format bitmap flag. So we'll just do RGA. And we do want bitmaps. And that goes in, just call it text for now. But you have to do this stuff in the right order. Image, implementation, platform. It should be visible. Do I have to ask for it explicitly? SDBI include SDB image H. Oh, we do see that. Oh, I must just have a typo. Did I forget the SDB P? Did I forget the P? Load texture from image file. SDB load texture from image file. Load. And what was the error again? Undefined, no external return in. Let's check it. It might be that if you stop and restart the stream, your latency will change. Thank you for that in chat. I mean, I don't think you explained it correctly, but you were close enough that I was able to see it. So now we say GL bind texture, GL texture 2D tech. Is that how you do this? Don't you also have to say which texture unit? Isn't there a whole thing where you bind the texture unit to? You have to set a uniform, maybe? Oh, but I'm using fixed function fragment shader, so it's just however you normally do the fixed fragment shader. Oh, enable GL texture 2D. That's what I'm forgetting. Except we also then need to disable it after that. Okay, what am I forgetting that I need to do to make that work? Let's make sure we're GL color 3F111. But I imagine that was wrong. Okay, what am I forgetting? Well, we saw that it worked with the other thing, right? We can put that on the ground. Text chord 2F 00. Go to 100, 100, 100, 100. Yep, okay. We're definitely getting that. So why does it not work in the other one, given that it is still running a fragment shader? So am I setting the text coordinate wrong with this stuff? 00101101. That's right. The Z value should be ignored. Is that the right thing to set? I need the ancient OpenGL shader cheat sheet. Yeah, but I don't want the 4.3 reference card. I want the old reference cards. There we go. So not fragment shader variables, vertex shader, special output variables. Oh, no, varying outputs. GL text chord. No, I did get it right. I write out GL text chord. We enabled it. Okay, I write out GL text chord, sub-0. We did enable it here. Why is it not applying it? We never know. We use some GL lighting. That doesn't need to be here at all. Just put it at the beginning, just to make sure. What could I be missing? What makes this black? We're back to debugging a black thing in OpenGL, as is always the case. Okay. I keep forgetting to leave this up. I should probably just put this in as a text overlay, actually, in the OBS. I just joined, but the general flow is active texture, bind texture, use program, uniform location unit. Yeah, I remembered there was something like the uniform location unit, but I think because I'm using unit 0, oh no, it's because I'm not using uniforms, right? I'm using the compatibility profile, so I'm just using the default fragment shader, the fixed function. And the point is I just did it up earlier in the code. I have it right here working. So the question is, why does it work here with fixed function, but it doesn't work here with fixed function? Right, I have a vertex shader, but not a fragment shader. So I'm using the fixed function fragment. What could I be missing? What am I forgetting about? Why are these two cases different? In the fixed function, in the other thing, it's a fixed function vertex shader, so it's definitely sending the data through correctly. In this thing, it's definitely setting the positions through correctly. We're not setting color. Maybe not setting color is the problem. Maybe the color is defaulting to 0. GL front color equals like 41111, maybe something like that. Aha, that was it. Okay, and then let's enable cull face if I haven't already. Let's put this at the very bottom. GL enable cull face. Aha. So we did screw up our face, which side to draw the faces. Why does that have a white border? Is it not set to wrap? Did I not enable wrapping? It should wrap by default. Right, that looks like it's pulling in bad bitmap data or something. Or it's using clamp to border. Yeah, I know the order of enabling and binding doesn't matter. Okay, oh, it's correct on the bottom, but it's wrong on the top. The top face is wrong and the bottom face is right. I believe the top face is the last one. Sorry. Positive Z is the last one. So the positive Z is wrong. Is the winding wrong? We go... Because I just took those Z values and reversed them, but maybe that's not right. Yeah, because I said it was going to be a 180 rotation of the top face, of the bottom face. And so that 180 rotation, the 180 rotation flips X and Y, but then we have to rotate it up to the top face. Oh, no, but it is correct that I do see what the bug is. That I did do the math wrong for that conversion. But what I want is, sorry, I did that where you couldn't see it. So what I was saying is that we want to transform from that to that rotated 180 on top, but you have to stay facing the same way. So you take that and you just rotate it that way. So that X value should stay the same on both sides. So so when we rotate, this should be a 1, a 0, a 0, and a 1. And then the X values should be, that's just the last one, right? Of the X values. So now it should be 1, 0, 0, 1, which has the value of 5, and it used to have the value of, 9, and it used to have the value of 6. So X, that's the high nibble, that should be a 9. Yep. So I made one mistake in computing the magic numbers. Okay, so now what are these whites? Oh, it's like it's getting a GL lines are being drawn. Did I not GL end my GL lines? I GL ended my GL lines. Why is it drawing lines? Is that because, yes, it is. Because I did not GL, where do I, oh, it's up here. It's because I didn't turn off GL use program. So it was using the voxel shader for everything else that I was drawing. Except now I've lost my fixed back faces. Oh, is that because I need to actually do the use program before the uniforms? I thought I didn't. I guess you do. Okay. All right. Now is everything is working. I believe consoles came out after VC6, but it just has a font browser, so you can bring in consoles. However, you can't in VC6 set consoles bold, so I had to do trickery for that. So yeah, I got something working, and so in that classic fashion, I'm going to take a breather. I don't need to actually leave the computer, so I'm going to start paying attention to chat. So if anyone has questions they want me to answer, that's good. And let me do a C mirror to save that data, because we have hit a good progress point. Yep, checking your code, somebody suggested. Which is exactly what running C mirror means. So we're on the same page. And we can go in here and we say, we check that off. And we check that off. And then, as it may have seen, showed up on the stream for a moment, I had a delivery coming. Where did I put it? So let's see if the delivery is here yet. No, it's not. I'm wondering if you're planning on sharing this code. Probably not. Have you been watching any good TV shows recently? I recently finished my second rewatch, my first rewatch of White Collar, which is a pseudo procedural crime show about a FBI agent working with a con man to solve crimes. That the con man is the same actor who on Chuck played the super heroic secret agent Bryce Larson. I am also had in the past been actively watching The Rookie, which is a propaganda show, but I just love Nathan Fillion, so I'd been watching it. But this season, the first 2 episodes, I couldn't get past the first couple minutes. Yeah, I should mention technique beam technique tech. I, I think the problem with why I can't pronounce it is that there's an old stereo brand that was something like Technic, but pronounced weird or something. Anyway, uh, yeah, the rookie may have jumped the shark ages ago, back once they started doing the international drug busts or whatever. But you still had stuff after that. I think like Daddy Cop, the Daddy Cop Cold Open was just one of my favorite bits of television ever, and it's a great acting from Nathan Fillion among like it's a good song, but Fillion sells that just so well because he has no lines. Well, he says wait a moment in the middle of Daddy Cop, but it's all just in his expression and his body language. So yeah, the thing I was going to say was about sharing it is that I am going to try to. My current plan is to try to do all of the engine of this on stream. So you will get to see how every single thing of it's put together. If I do any work on it off stream, I'll try to review it on the stream. Which is basically why I streamed Voxel Friday yesterday, was because I wanted to start working on it. I didn't want to wait till Friday. And so I felt like I should stream it because it's a unique enough thing that it seems interesting to stream at least this whole building the mesh part of the tech. Like, I don't know what game it would be, and so I don't know that if once it becomes a game, I'll do that much more. But it doesn't quite all fit on the screen. Let's do this. So this is just the same exact data rotated horizontally, or rotated, transposed. Transposed is what I mean. So let's see if we can fit more of it on screen. And this can become U-3. Let's just do it by deletion. This is actually going to take more rows of code, but a little bit cleaner. That can actually just be magic number, shift right. U-3. Well, it's the same math for all of them. Oh, okay, so that just boils down to this. I believe. Let me run it real quick and make sure I didn't break it. Yeah, okay. Maybe Audio-Technica is what I'm thinking of. Yeah, no, I realize it should be technical without the al at the end. I just feel like there was some... No, I think the brand was Technique, like with the Q at the end or something. Anyhow. What? Why did that... Oh, techniques. That's what it was. Yeah. which I think how it's pronounced in the U.S. I don't know how it's actually pronounced in Germany, but I'm pretty sure it's not pronounced techniques. I'm pretty sure in the U.S. it's pronounced techniques. Thank you, Jay. Oh, that's interesting. It's Japanese. Oh, okay, yeah. So then that's obviously not even got a Japanese, like not. Obviously, the Japanese pronunciation would have no bearing on the English pronunciation, since it's that kind of brand name. What was I going to do? Oh, Daddy Top. This cuts out the very beginning. This is seen at the very beginning of the episode, and they cut out the first like 10 seconds or something, which is somebody rolling through a stop sign or something that sets it up. Yeah, just people generally don't use geometry shaders. I mean, usually you don't use geometry shaders largely because the amount of output is varying, and that is poorly handled by the GPU, which is something you can find on the Rig blog. I think it's part of the graphics pipeline series. So in general, people don't use geometry shaders, and so for that reason, I just didn't even think of it. Like, just wasn't relevant to my concerns. But the only cost here is having the indices. That's compared to a geometry shader, I think. And actually, I will have to make the indices 32-bit instead of 16-bit. But it'll just be one shared index buffer that's used for all meshes. But probably, maybe in this particular case, geometry shader would be better. I don't know, having no experience with them. What's next for after the break? Well, let's see what was on the playlist. So I want to start having the GPU do the mesh conversion. So, So first, I want to make the texture array. I want to load a bunch of textures into a texture array and have the CPU construct them construct better texture data. So that propagates that data in. And then, so we can see different textures on each side. And then we'll have the GPU do some kind of test meshing. And then we'll have the GPU, then we'll start doing command lists. So it's not like I was doing this command list stuff now because I knew we'd get to it pretty soon. Most of the time that has been between when we started and now, we're now getting close to it. And most of that time was spent just debugging stupid OpenGL stuff. Yeah, but I'm not going the compute shader route for it because it's transitory. So mesh shaders or a vertex shader or a geometry shader would be what makes sense. And like I said, this might be a case where the geometry shader isn't slow. I'm not sure. So probably the old ZMC is probably using texture arrays. Our world. Oh, except this doesn't use platform, so I haven't written any code for that yet. I don't think Big Ships uses it. I don't think Voxel uses it. All right. Well, I'll figure out how to use texture arrays from scratch again. So it's GL texture 2D array. Yeah. So we have GL texture 2D array, and I think we use cube map, not cube map. I think we use 3D tech. We create a 3D texture is how this works. So we want to create a texture and then start loading it one at a time. So we can't use load texture from image file. We do GL gen textures text GL find texture 2D array tech GL texture storage 3D. That's what somebody suggested in chat. Do I have I defined that in platform? No, I haven't. Texture 3D. Text 3D. What? Am I in the right file? I am. Have I not? No, I've definitely done 3D texture stuff with this. Oh, I do have text storage 3D. Oh, it's just not autocompleting. Oh, it's text storage, not texture storage. Gosh. And you, of course, got that right into the chat. Okay. 2D array. Size, enum, size. So the last three sizes are obviously that. The first size is the bitmap level, maybe? Shouldn't the just text storage... Do I have to do one of those for every MIP level by hand then, I guess? Or can I still use GL generate bitmaps? And then the enum is going to be the internal format. So... how big are these textures? Oh, I can't. I don't want to use these. I want to use something else because these are random weird dimensions that OpenGL is resizing for us or not or whatever. What other textures do I have that I can use? Oh, I can just use Image Magic to resize. They're not square. Yeah, let's look at other projects and see if I have some existing textures I can use. No, because I don't do that much outdoor 3D stuff. Or 3D stuff at all, or like real 3D spaces. So I don't know that I have any sets of textures lying around ready for this. but I'm not going to spend the time on it now. Like gathering. I have a whole bunch of textures. They're just not like prepped for use. These aren't really prepped for use either. So yeah, I guess we'll just image magic it. Purge games CMC2 CD data CD textures. Do I have anything else that's in here? Because the directory already existed. Okay, so magic, modify, resize, 1K by 1K, star.jpg. And maybe I totally break it by doing that. Maybe I'm doing something wrong. I did not change anything. Oh no, that's the old ones. Yep, okay. Now they're K by K. In fact, we can copy the array list that we had in here. Oh, some of these were... Oh, these are actually being pulled from a different source, I think. Yeah, because they were coming from a subdirectory. So I stopped using these, and I was using ones from a subdirectory. Except the subdirectory doesn't exist. Maybe this is... I don't know. Alright, well, you won't use that. So this is 1K by 1K by 2v6. And then for an I equals 0, I less than 10. Static show star files equals okay, that's probably enough. 1, 2, 3, 4, 5, 6, 7. Let's just fill it out to 10. Or actually, we can just fill it out to 10 this way. And then get this prefix. Dun, 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 dun. Okay, so now what do? We have to use something, text sub image 2D. I guess it's text sub image 3D. Text sub image 3D, which looks like this. As I mentioned before, this is how I used to do it. Nowadays, I would still have the names in here exactly so that I can do this. This is GL texture 2D array. We need to actually load the image. Is SB I load files of I width height. This is for 4 channels. Width height. So then this is GL int, GL int, GL int. I have no memory of what all these parameters are. Obviously the 3 steps. Oh, it's the MIP level, and then the position 0, 0, I, and then the size, width height. It should be 1024 by 1024. 1, and then the format. GLIFGA, the size, which is unsigned byte, the data, and free it. That's a U8 star pixels. That needs a semicolon. Okay, and then down here, when we use it, we don't do it here. This gets a 2D texture array. And we run it and see if we still get the texture. The file names are wrong, or the directory is wrong. CMC to data textures. And am I running from data? I'm running from data. So the directory name should be right. The file name should be right. Files of I. Oh, it's because it's null, because we looped. I forgot to. Yeah, okay. So we have to exit because we broken the debugger and relaunch. Yeah, this is just has to be if files of I. It's not null. I just forgot that. Okay, so now the question is, do they still all use the first texture? No, they're not textured anymore. The ground plane not being textured is expected. Although it's super annoying looking. Where do we draw that? Here. Yeah, no, I could, of course, have always looked up the reference page for text sub image. That's what I usually do. But since I knew I had it sitting right there, since I just looked at it, so I knew if I just tapped in, I would have it. And then I realized, oh, no, it's not the right one. So I did it from memory. So yes, maybe I didn't do it correctly from memory. So let's take a look at the official ordering. And level, offset, width, height, depth, format, type. Yeah, I did get it right. I did correctly remember it. So we're not. It has no mipmaps, and we're not setting a thing. So GL generate mipmap GL texture 2D array. Is that what the texture that is? No, you just say GL texture 2D array, I think. Nope, that didn't help. But okay, well, let's do the GL. I don't remember the thing offhand because now you use this library all the time. Load image. No. Create texture from image. I just want down here at the bottom this. Ding, 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 ding. So you need GL linear. The whole thing is that if you don't, by default, you get a minimization filter that wants bitmaps. But if you don't define bitmaps, your texture now is invalid and it won't sample. Okay, so that still wasn't it. Let's make sure we're sending through a 0 for the data. I think we might just, yeah, because we passed in 0 when we build the voxels. Yeah, that's the 0 here. But let's just make sure we pass in a 0 here. Yep, we do pass in a 0. It's not helping. And actually, it's white, which actually means we do have a texture. No, white means it's a bad texture. White under old OpenGL means it's a bad texture. Oh, I didn't do this. So this attempt to fix this might not have been correct, and that still could be the issue. Yep, Maria mentioned that, but it's not it. That's the fun of this, of the OpenGL 3D debugging, is you catch mistakes and you fix them, and it's like, no, that wasn't the mistake. Like, maybe that contributed, or maybe it didn't matter. Like, who knows? What else could I be doing wrong here? Yeah, the files are being loaded. We know that the files are being loaded. So yes, slashes valid from the C libraries. It does support forward slashes, but do you also need to wrap S and T? I believe the default filter mode is to wrap, but also it doesn't matter because I'm always handling them 0 to 1 without wrapping specifying. So if repeat is not the default, I will turn it on, but it shouldn't matter now. No, I have no experience with D3D or Vulkan. What could it be? What could it be? Did I not quite convert everything over to 2D array? Did I leave out an array somewhere? Bind texture, geotexture, 2D array. Disable geotexture, 2D array. No, that seems reasonable. I guess I could try to make the ground texture use it and see if it works for the ground texture. Right. Because that's like, I know what's happening a little better here. Now we need to put these back to 1, 1. Okay, let's do the explicit third. Let's say comma 1 just to mix it up. It's all white. It's still seeing all white as well. So we don't have to worry about the shader. We can just think about what's going on here. We use text sub image 3D to update. We use text storage 3D to allocate. Text storage 3D never gives it any initial state. Is the order of that right? It might not be. I might have the 0 in GLRGBA backwards. No, because it was an enum. This one was an enum and this was an int. So it must be the right order. GL, but we'll check anyway. But I'm pretty positive. Target levels. Oh, I have to tell it how many levels I want? It infers that from width, height, and depth, doesn't it? Maybe it doesn't. No, I do have to tell it levels. Well, maybe this should be exactly one level with no bitmaps, right? Oh, it would have to be a 1. I bet if I do this, it fixes it, but it won't support bitmaps. Nope, it doesn't fix it. Well, let's specify 10, or is it 11? Not sure if it's 10 or 11. What else could it be? Yeah, I think 1 is correct for no bitmaps. So I think it would be 11 to get the full bitmap array. So in fact, let's stick to that, just so that bitmaps don't mess things up. But I know this didn't work. Yeah. So what else could it be? Yeah, I don't have 10 files, but it fills out the rest of the array with zeros, which are nulls, and so I test for that here. What else could it be? Let's see. What else do I set for text parameters in this thing? Okay, upload the texture, swizzle, bitmaps, filters. I don't do anything else. Yeah, I don't change clamp by default. Did I get text image? No. The second parameter is the bitmap level. The array indexing is treated as the Z or the UVW coordinates for the texture coordinates is treated as the W. So the index belongs. So you have a width, height, and one slice of the array, and the location of the array slice, it's at the origin of the X and the Y, and it's at the ith slice. We just had it working with 2D, so the basic stuff of what's going on isn't wrong. So what could we be doing wrong? Except, yeah, I was doing it through the platform wrapped function, so the details weren't being done out in the open. Invalid formats, but I'm not getting. Well, do I still have a breakpoint here? Message. So what are our messages? Okay, we saw that one before. Aha. Aha. Do not use this function for geotexture 2D array. I have this open right here. Target levels, internal format, width, height, depth. GeoTexture 2D array is a valid target. So what's wrong in this enum? Which parameter is wrong here? And the answer is I did lose my breakpoint. GL invalid enum error generate. Internal format not supported, but the internal format is supposed to be RGBA. Right? Isn't that the internal format? Target levels internal format. How can RGBA not be supported? Is this too big? Oh, maybe it's too big. A megabyte, 256 megabytes, a gigabyte. I don't think that's too big, and I don't think that would be the error you generate for it because it's an invalid enum, right? But so I don't think that's how it would show. But we'll make it smaller anyway. Because what we'll do in the long run is use BC1 textures that won't take up that much memory. Internal format not supported. How can GLRGBA not be supported? Oh, that's not an internal format. That's why. That's the public format, not the internal format. Anyway, yeah, if I hadn't lost my breakpoint, we would have found that a lot faster. Oh, no, that's still not it. Unless I'm... Is that now in the tail text up image? Oh, I just changed it in the text up image, not in the... But yeah, if I hadn't had that breakpoint removed accidentally, we would have immediately known where it was going wrong. And then I just forgot that we had that possibility. Okay, now we get a different one. Aha, yes. This is for an enable or something. Why is that wrong? Why? How is that wrong? How is that wrong? Let's go look at ZMC1 texture array texture array. This is our world. Our main, maybe? Doesn't this use texture arrays? Don't tell me it's using a separate... No, there's no way it's not using texture arrays. We saw it using texture arrays. I just don't know where we saw it before. Unless it's using a... Unless it's using an atlas. It might be using an atlas. Oh, yeah. It's using an atlas. I think this is old enough that it wasn't positive arrays would work. Don't you do the texture arrays by doing the same kind of GENenable stuff? I thought that's how you do it. I've definitely done this. It's in some project of mine. I don't know which. I guess I can grab it. Grep 2 minus D. Searching for 2D array. Star.c. It's in Vox 4. Not Vox call. Vox 4. Oh, yeah, it's in OBBG is the answer. Yeah, you just GL bind texture it. Why is that an invalid enum? Don't tell me I set the enum wrong. GL texture 2D array xglx.h. It should be 8c1a. Eight C1A. 8C1A. That's what my GLX has. What could it be? What am I missing? I don't see how it could be any of that, but let's do it just in case. Yeah, 0, 0, 0 slice with height 1. It's exactly the same. Oh, except this one doesn't say RGBA 8. Why did this work? Oh, right, because this side is describing this side. So yeah, it's the same. It's GLRGBA 8 here and GLRGBA here, RGBA 8 on the storage. I don't know. It looks like exactly the same thing. I don't see what's different. No, invalid enum generated. We might not be in synchronous mode, so it's possible. Oh no, I did leave it in synchronous mode. Like, how can it be a valid enum for text parameter and not be a valid enum for enable? Let's make sure that's the thing that we're actually hitting. Oh, I accidentally disabled it. Yep, that's actually which thing it's dying on. How could that happen? I don't understand. How can we bind the texture fine and die on GL enable? Are we corrupting memory and breaking GL? Like what? All right, let's just go back to enabling texture 2D and make sure that doesn't break. Okay, we still have the thing. Like it won't work, but I want to see if it. Aha! Oh, no, it's dying somewhere else. But that's also still weird. What's it dying on? Wrong component type or count. But we weren't getting this before. We weren't. I had lost the breakpoint, so we might have been getting this before, too. Isn't it a UVec 2 now? Chunk origin position is a UVec 2. Oh, it's UI. And now it'll be at the other spot where we're doing it. Yeah. Did I disable the breakpoint? No. Oh, right, because, yeah, we're just... So texture doesn't exist. Okay. So, yes, if we switch it to where is that? Here it is. If we switch it to 2D, it works. What if we switch it to 3D? It's fine. But if we set it to 2D array, it breaks. And I've used this before in Vox 4. Is Vox 4 based on STB platform? No, it's OBBG, so it's SDL. So this really could be an STB platform error. But I don't know how, because it's the same enum that gets used for the text subimage. But it could be that STB platform's OpenGL thing is causing a problem here, because this may be the first time I've done texture arrays with it. I did a grep for that, so let's go back to that grep. Here's the grep. Box 4, box 3. These are all going to be OBBG derivatives. OBBG hats is probably an OBBG derivative. KView was STB voxel render, so that predates the platform stuff. Yeah. Big ships DDS loader, but I don't think I used that yet. That's in there. Big ships render. Oh, no, wait. I do use it for bind texture, GL texture 2D array, right there. Okay, let's load up big ships. So yeah, that's how I do I talked about this tile map thing. This is being, even though it looks like hexagons, it's being done with a bunch of square tiles, slightly stretched. And the tile data, I think it's stored as an atlas, but then I turn it into a 2D array. And it could have just stayed as an atlas. It doesn't actually get the normal benefits because it's doing the bilayer itself. But so that is using texture arrays. It is using STB platform. And we do not get an error when we bind texture here. Well, maybe we do. Let's go to STB platform. Message. Yeah. Yeah, this one we're set to actually get to break on any kind of event, and it doesn't break. So it's definitely working in this, but it's not working in this. Why would that be? I do not know. Yeah, let's look at all the setup for it. Let's see how it's built. Bind texture, geotexture rate, that. Geotexture storage, that. Geotext subimage, that. Geogenerate bitmap. There's a third axis you can wrap, but I can't imagine that matters. Let's allocate space for the bitmaps so we can calculate the bitmaps. But why would that cause an invalid enum? Even if there were mistakes there, it should never cause invalid enum. That's just a wrong error. Maybe I need to reboot? Right? Like maybe my OpenGL is a little fucked internally or something? Because I don't understand how can you get invalid enum from enable for something that's clearly valid? Like if the GLTexture 2D array state was invalid, you'd get a different error message or no error message. And you'd just get a black texture. There's no reason it would do this. Yeah, and why does it work on big ships? What's different? Well, that's the point, is like it's doing a bunch of different stuff, other stuff, so maybe it makes the OpenGL into a weird state in this one and not in the other one. Do you even need to call GL enable for this? Yes, because I'm using fixed function. Oh, it's not using fixed function in big ships. That's the difference. What version of OpenGL are we asking for? 4.1 with compatibility. But the shader is 4.3, right? I'm never gonna win that race. Yeah, I highly doubt that rebooting would fix it, but I don't know what else to try. I can't think of what could cause this. Getting an invalid enum, it just means that the number that's being passed in here is wrong. Is somebody else redefining it? Debug. So it's just DBG print. I don't remember what it is. Debug out. Oh, it doesn't take. Okay. 8C1A, which is definitely what I put it in the header file. And we're going to look one more time at what's in GLX. But again, this wouldn't change between fixed function and like, there's just no reason for it to produce. I have to assume that this error it's producing is invalid, I think. I think that's what I have to do. It's just assume that's a bogus error. What happened to my... Oh, I F-zeroed them out. Because it just doesn't make any sense. I think I have to assume that's a bogus error. That's because you're looking at GL2, and GeoTexture 2D array is probably after that. As we just said, it's in the other project, it works fine. Yeah, so I don't see any reason that if it's a valid enum, it's always a valid enum. So if it works in the other project and doesn't work here, it's got to be a bogus error. Whether that's because the OpenGL is in a broken state and is producing a bad error, or whether there's just a bug in the OpenGL thing, I don't know. But since it also doesn't draw, this is all very suspicious. It's also not in GL4. Oh, maybe because... Yes, it's being ignored in big ships. If it's even big... Was I enabling it in big ships? I thought I looked and saw it. Array 2D array. I thought I looked and found it being... Yeah. Oh no, I bind it. I don't... Yeah. So you don't need to enable it if you're not using fixed function. You only need to enable it for fixed function. And so the answer here must be they don't support it in fixed function. And that's why it's giving you an error. Which is weird that they wouldn't back support it into compatibility. Like, I bet if we look at GeoTexture 2D array extension, OpenGL texture array extension, I wouldn't be surprised if they X texture array 2008. I mean, it's late enough that they might not. So then they say GL enable. Okay. Yeah, so maybe they just assume that you're only using it from shaders. Or maybe I'm forgetting maybe you don't need to enable it and there's some other thing to do. Maybe you enable texture 2D. That's what it is. You enable GeoTexture 2D. Yeah, I don't need the active thing. You enable 2D GeoTexture 2D. That's what it is. They're both part of the texture 2D slots. I remember this. Oh, no, I don't remember. I'm pretty sure it's something like that. There's something like that. Maybe it's 3D? Maybe it's part of the 3D slots? There's something like that where you enable it with, so let's read it in here. Let's look for enable. Let's look for enable. I hate the fact that they leave out the GL prefix because it makes it impossible to search for stuff like this. Right? I want to find GL enable in here. So it's capitalized enable, but will this let me? Oh, it does give me a match case. Let me. Where's my cursor? There it is. Match case. Now, if I search capitalized enable, do I find? Aha! So they just didn't do it. They could have done it, and they didn't do it. Jerks. I still think there is something, like I said, though, where they kind of alias their slot names. Okay, well, thanks, guys, for wasting all that time of mine. I mean, it's my fault. I'm doing this weird, esoteric, idiosyncratic, mixing fixed function and non-fixed function all over the place. But it's just trying to be fast, right? It's not worth stopping to write a fragment shader if I can just use the default fragment shader. So I want a simple. Does this one have a simple generic fragment? No, this is doing a lot of complexity. Test fragment? No, that's doing stuff. Who's going to have a simple fragment shader? Where are the fragment shader? Simple fragment shader. There we go. Okay. Here's the MC2. New text file. No, not RT. Thank you. MC2. The file name is Voxel fragment. I mean, we were going to maybe want this in the long run anyway, so it's fine. But data shaders. And what does this do? Now we don't get access to the fixed thing, so we have to actually pass that data through. So we need to have a U vector, or not a U vector, a vec3 text chord out, we're in rather the fragment shader, and I guess that's it. And then in the vertex shader, hello, why is this not insert file into project? Why can't I insert this into, oh, because it's already in there. So then the vertex, it's that. How do I still use GL position? I forget. We don't need front color now. And we say text chord. And we say text chord. And so now we go, we need a uniform. So I never remember how to do samplers. Sample 2D array. Textures. Check for out color out. And then we say tile data. Oh, I never actually got to using it. Well, okay, here's. It's in util. Texture. Sampler 2D array. Tiles. So where do we do tiles? Texture LOD. Okay, so it is just a normal texture call. So it is just out color equals texture of textures, comma in. No, not in. Text chord. I think that's all it is. So what have I forgotten to do? Let's check what chat said. Nobody said anything. So I'm sure I messed something up in there. I put the in and out at the beginning. And it's an out from the vertex shader. Compatibility. Visual C++ has syntax highlighting, and it's still wrong. Out color equals vec4 1010. Yeah, so I'm doing something wrong. Oh, we're not using that. This is just drawing the ground, and the ground isn't using that shader, and it can't use that shader. So we disable this again and go back to the voxels. And maybe it's just working, if we're lucky. Yep. There's that magenta. No, it's black. It's still not working. The texture still isn't working. Textures, sampler 2D. Oh, I haven't found it. Yeah. Main. So, we don't need enable or disable. Instead, we say GL active texture, GL texture 1. Because we bound it to 1, so I'm hoping that means that's in the 1 slot. Yep, okay, good. Okay, and now we give them different textures on different sides. That's what we've been building to this whole time. So what we're going to do is we're going to specify text 0, text 1, text 2, text 3, text 4, text 5. We're going to pack those in an array. Text 0, text 1, text 2, text 3, text 4, text 5. It would be an array of 3, 2. And then this gets array of I of 0, array of I of 1. Oh, I forgot my ints. Replace tech with int tech. And then we got the 1 doubled. And now we need to actually specify the textures for these. Okay, are they different on different sides? That one's not different on different sides. Oh, that's the one where I only put, yeah, where I just made the opposite sides be different. Yep, okay, hooray. Wasted a lot of time because I'm using OpenGL and that dumb thing wasn't supported. Why is that bottom black? Oh, I went out of range. 7 doesn't exist. It only goes up to 6. That's fine. Okay, look at that. Now, my grocery delivery has been delivered. Okay, so I'm going to go bring that in, and then we will take the next step. Let's check that off the list. GPU builds text. Oh no, yeah, this was supposed to be a tiny step before I did this GPU thing. I just need to enable texture arrays. Oh god. Yeah, let me save the code. Version control. Well, it's not really version control, but pseudo version control. The Casey thing. C mirror. All right. And look at this. We mentioned yesterday, I've been programming for 46 years. And look how excited I got when I fixed the stupid OpenGL bug. The M in C mirror stands for mirror, so it's C mirror error. All right, anyway, I'm bringing the groceries. Okay, let's see what chat has said. Why OpenGL and not DirectX? Because I learned OpenGL and I never learned DirectX, so I continue to use it. I've talked before that I don't really like switching things because I have to learn something new. And DirectX, if you went to DirectX, you'd learn DirectX 9, and then, oh, you got to stop using DirectX 9 and start using DirectX 10. And then it's like, oh, you got to start using either DirectX 11 or DirectX 12. OpenGL added a whole bunch of new features that you did have to learn as the GPU is upgraded. But, as we see, I still use immediate mode. So I still use all the old feature sets. Of course, I just got burned by trying to use an old feature set, but... okay, so yeah, let's move on to the next step. GPU builds test vertex buffer in this format. So it's just gonna do something dumb. The goal is not to have any smarts. I just want to make sure I know how from the GPU to write the data. I think it's going to be totally straightforward. So we go to voxel vertex and we save this out now as GPU as compute measure .glsl, and then we don't need these, but we do need this. We'll have to output the size. But it only needs to be readable by, if we use draw indirect, the size will only need to be readable. So yeah, okay. We won't do that right yet. We won't do that correctly yet. We'll just have the CPU magically know the size, the amount of data that got generated. So we do a uvec2. It's exactly what's over here. Make voxel. But we'll use field insert. No, we'll use this code to do it. So make voxel face pair is going to return a uvec2. Going to take uints, so we don't have to convert them all. That's going to have a uvec2 data equals uvec2 that comma that. We just return it. We don't need to assign it. If there's a whole category of keyboards, I don't think you had that keyboard back in 2012. You had some keyboard with a similar sound. And so then I think what we want to do probably about questions unrelated to the stream is probably wait until I'm taking a break for that. You can ask the rest of the chat, but if you're going to at me about stuff, it should probably be related to the stream while I'm coding, just because I need to keep stuff mentally. I don't want to swap in and out. It was a little different when I was streaming OBBG because it was more for the audience, and so I was probably more willing to swap. But I probably need to not, like, I just haven't even read what your question is. I probably just need to try to stay in my consistent mental space. So I think the answer is no. Okay, so then if we want to make a voxel, we say uint make voxel uint. There could just be an in out then, right? Uint in out, or in out uint, I guess is the right way to do it. In out uint offset int x, int y, int z uints. uvec 6. I guess there's no uvec 6. uvec 3 of text positive, uvec 3 text negative, and then the way we do it is we say uvec 2 v equals make voxel. It's a face pair actually, so it's a fp equals make voxel face pair x comma y comma z. Not, you're getting the old definition, not the new definition. They're not autocomplete, so it's confusing. Make voxel face pair x y z face pair text positive x text negative. No, that's negative first. Text negative dot x text positive dot. I should probably do them in the other order. That's counterintuitive to have them be. And then we write voxel mesh of fp no, voxel mesh of offset plus plus equals fp. So we could just do that directly. Don't need fp. Okay. So that's how we make a voxel. And so then the main thing in our compute shader, every lane should write a different voxel out. So we will say, yeah, let's just make like a vertical stack. So we make voxel, what's the compute shader lane number? Active? No. It's been, I haven't looked at this in a little bit. So it's in box call. Compute column shader. Global invocation ID. Oh, we can actually do 2D or even 3D. Global invocation ID. Right, I need to switch that. So we have slot. Here's GL global invocation ID. Is that the one? What? There's one that's flattened from X, Y, and Z. GL global invocation ID. No, that has the. No, but there's one where it's flattened due to a single value. I can't think what it's called. GL. I think it's related. I think it might be only a local one. Yeah, index, but I don't think there's a global index. GL global invocation index. I don't think that exists. Yeah, it doesn't. Wait, and that's actually what I want. But that's fine. We can compute it ourselves. How would you compute it? Well, let's just use local. Local invocation index times 3, because we're going to write 3 base pairs per voxel. And then we say GL local invocation No, you can't just replace the locals with a global one, because now you need something bigger than work group size. You need work group size times whatever the other thing is that one's scaled by. So make voxel at slot. You get GL local invocation dot x times 2. Let's space them out so we can see them. Oh no, they'll have different textures so we can see them. GL local invocation dot y. GL local invocation dot z. And then the texts. Text evoc3 111 times local invocation index mod 7 plus 1 mod 7. So maybe it's something like that. And that's called compute measure. So we go to main. How do I build a compute shader? GL compute. This should be compile shader instead of create program. Okay. SWP compile shader. GL compute shader. Yeah. I'll have to load the sources. We'll just use frag of 0. SB file shaders. Oh, let's not confuse things that way. Char asterisk compute. Compute of 0 shaders. Measure free compute. Sources are compute. Num sources are 2. I guess is how that is what that takes, and then we need an error. Size of error. Compile shader. Oh, wait, compile shader. If we get an error, we call glprog error. Is this going to automatically produce something? Prog error. Oh, that's just concatenating strings. So we need to breakpoint here. Although it might automatically breakpoint in the other thing. I think 2 is not the right thing to pass in there. What is create program do? What does create program pass in? Oh, -1, yeah. Which means look for null terminated list. Okay, we did get errors. Error. We didn't get any error message. Oh, we haven't run the... There. Okay, now. Okay, if I run it, do I see that anywhere? No. Oh, we get an invalid free. Yeah, that's free compute 0. So create program. How does this respond to errors? Does that. Okay. So that's what we do here. So meshify equals equivalent meshify. Meshify is 0. Show error. Compute measure. Somebody noticed this thing, but I didn't see it because I didn't look at chat. And then I didn't finish this. I have to do the local, whatever that syntax is for this. This. So we'll do 32 wide, 4 tall, okay, 4 deep, and 4 tall. And 8 tall. Local invocation ID. Asian becomes Asian ID. And I accidentally typoed. It's a game engine. Who knows if it'll become a game? Okay, well, we still have the CPU stuff because we're not calling the compute shader, but we compiled it without error. So now we get rid of this one, and now we replace it with GLU's program meshify, is that what it was called? And then we have to run it, which you do with GL, I forget how. So this is going to be in render voxels, dispatch compute. Right, so dispatch compute. We just want to run 1. And we need to set up the buffer. So setting up the buffer should be the same as it is down here. Right here. I think it's in slot 1 in this code. No, it's still in slot 0. Okay. And we don't get any data. And oh, we got one thing of data. I local size Y twice. All right, thank you. Why did it not complain? That seems weird. But the other thing is that at the moment, I'm still only passing in index data for 3 voxels. So it should still only draw the first 3 voxels if I ever get this working. Now it's not drawing any. Oh, there it is. Okay. It's still the same. It's drawing the 1 at the origin. So now what does that mean? Are they all drawing the same thing because the local invocation ID is wrong? Is make voxel wrong? XYZ 0, 1, 2 face pairs. Why are we not getting all 3 faces? Oh, I didn't set. No, I did do this. So it's times 3. Like that could even just be all 0 data, and maybe that's what all 0 data generates. So it might be like we're not actually generating anything. I have to say that maybe or something. Oh, I have to do a barrier on it, maybe. I don't know where the in-out goes. OpenGL does not allow global in-out variables. It requires varying variables to be created in global scope. Okay, so in-out is just a synonym for varying. How do I make a writable? Okay, with the compute shader for Vox call for the no, it's writing to a texture. These are all writing to textures, I think. I don't know if I have code that writes to a shader storage buffer. So yeah, let's just look at OpenGL compute shaders. On the wiki. Share storage buffers. We don't want shared. It doesn't say anything about it. It just says you can do it. I might have to tell it that the thing is, it can see the dependency on the same shared storage buffer is used in the compute shader and in the draw, and so it should know about that and automatically address that, I think, which is one of the reasons why OpenGL is slow, because internally it has to do that kind of processing, I think. X plus equals 10, y plus equals 10, z plus equals 10. Let's get it away from the origin. Nope, it's still at the origin. So I think that might just be 0 data at the origin. So we're probably drawing 3 face pairs that are all at the origin, and this just isn't writing. Where does the out go? Because I'm pretty sure there was some syntax where the out went there. There was some type of thing. Oh, wait, that was that varying thing. Write to shader storage buffer from compute shader. Let's not use AI. This guy doesn't say anything about how to declare it. Vulkan. I thought it's still under Vulkan too. Fuck it, what's the AI say? By default, they're read-write. So it should be able to write them. That's the uninitialized data. I don't know what I'm missing. It's not out, it's write only if you want to use it. But it doesn't matter whether it does say it defaults to read write, so I don't see another one anywhere. So something about this isn't working, or we're not running it. Dispatch compute 111. Or does this need to be... does this need to be 3248, or does it need to be... That always messes me up how they do that. Because I don't want the global thing. Time to try the barrier. Well, here's why the barrier doesn't matter. Is because I ran this compute shader at the beginning before the loop. And then inside the loop, like eventually it would become coherent. So eventually the rendering would catch up. So then that would happen in a couple frames, if not in the second frame. So I'm pretty sure there's no need for a barrier kind of thing. There might be to make it work properly, but for us to see something, there shouldn't be. Okay, where's that wiki? Close that window, close that window. I have a ton of open browser tabs. OpenGL, GL compute shader. Okay, dispatch is the work group count, not the number of items. Okay, so 111 was correct. Do I know that anything is actually happening? No, I don't know that this is even running. In fact, all evidence is that it's not running. So it's either not running or... I don't know. What? It's read-write by default, so let's just leave that alone. I am starting to voxel mesh in make voxel. I am calling make voxel. So if this code is running, it should be writing into the thing. If the code is not running, it would leave the memory uninitialized. And it's slot 0. Yep. Maybe I do need to do that uniform thing. Let's look at how I do it in ZMC too. Maybe I do need the uniform to do the mapping between the binding. But I thought that's the whole reason to use binding, is then you don't need it. Wait, who was it who had the shader storage buffer? Oh, this does have some. Yeah, ground shadow. Okay. So we want to go find shadow, ground shadow in render voxels, ground shadows. Yeah, you just put it in the right slot. Yeah, that's all, should be all there is to it. Right? There's not something up here establishing these. Yeah, no. No, it's just that is the bind point, and that's the whole point of this API. So what is happening here? I went through this. We're either not writing or we're writing wrong, or we're not running. And I don't know how to debug any of those cases. This doesn't need to be an in-out because it's all being done in parallel anyway. It doesn't hurt though. We can switch it to only updating the first one, but let's switch that back. Not that it's going to matter. What could be happening? What could be going on here? What could be happening? Definitely hit this code. Let's look at this again. Dispatch. Let's make sure we still have our error error breakpoint. We don't. Aha! Program has not been linked, or is not. Oh, I only compiled it and didn't link it. Okay. So that's not how I initialize a compute shader. How do I do a compute shader in this guy? Compile shaders. It's in here. Oh, I just manually link it. Right, okay. I just never upgraded it to support compute shaders properly, and so yeah, I wish I didn't. I just habitually disable that breakpoint so that I can try to run further and then forget to turn it back on. So this is glue int comp equals compute shader meshify equals comp So yep, I wasn't running it because I was hitting an error. Oh, that's because this didn't get changed, which somebody mentioned. Aha! They're not spaced 3 apart, or 2 apart. Didn't I double? Did this thing be times 2? Oh, yeah. I never actually did the times 2 that I was planning on doing, which I wanted to do this way. And now all we have to do, it's already building all of them, we're just not seeing them, is we change this. And then we say we have 3 times, and whatever the dispatch count was again. Or the 3248. 3 times 3 times 4 times 32 times 4 times 8. There you go. So there we just had a compute shader in parallel build a whole bunch. And that is, yes, absolute victory. So we have the computer build a bunch more. Well, so first of all, let's switch to 32-bit indices. So we can have more. Just unsigned word, unsigned int. And then let's have our dispatch. Our dispatch is going to be our Y depth of 24. So this gets an extra factor of 24. And then we need to use slot gets plus GL global or GL work group index, work group ID, GL work group ID. Is there a work group index? Probably not. Nope, there isn't. So let's compute a uint GL work group index equals GL work group ID.x plus GL work group ID.y times what? Have something GL num work groups? Yeah. Times GL num work groups dot x plus GL work group ID dot z times GL num work groups dot x plus GL work group GL num work groups dot y. That's times. That's capitalized. Okay, so that is our work group index, and so then our slot needs to be the GL work group index times 32 times 4 times 8 plus that local invocation index, all that. And then we actually want to use global invocation IDs here for the position. And we could change these, but it's just for visualization, so it doesn't matter. Okay. Stack Overflow. Great. What did I change? Oh, I allocated this on the stack. I forgot the underscore somewhere. Yeah, okay. Yep, somebody noticed that in the chat. You can't start a name with GL underscore. Fun. Okay, and now I don't see it having replicated. So did it not offset? No, that should just automatically happen with the global invocations. Did it not offset the slots correctly? Is the workgroup index not correct? Well, anyway, it's designed to expand in all directions, so let's do that now. GL dispatch. So the x extends out by 8, so it could go another 8. That'll be 64. The y extends out. Oh, it's extending vertically. I didn't look up, probably. The y can go out to 256. It's currently 4. but doubled 8, so it could go 16. And then the Z is currently 4, and it can go up to like 4K. So it's 4 doubled is 8, because there's a space between each voxel. So 8 into 1K is 128. So we'll make a really big thing. So first of all, they bump into each other and they're not tall. So it did do it along one axis, but not the other axes. Is that how far 256 is? How many x's did we do? We did 8 times 8, 64. That's only 128. So it should be only be 64 blocks along x. Wait, no. Is that 8? Was it 8? No, it's 32. 8 times 32 is 256. Oh. Yeah. So you can only do 4. I was looking at the wrong numbers. Y goes up to 4, so which uses 8, which is 16, so that's fine. So these should all be fine. We're just not. Let's see if anybody noticed a bug. Nope. Okay. Oh, and actually Z was larger than I thought, so let's limit this to 32. We could also be running out of space in our buffer. I haven't tried to measure that. So how many things are we making? But I don't think we'd be at it. So this is making 2 to the 5, 2 to the 2, 2 to the 3. So 5, 6, 7, 8, 9, 10. So it's 2 to the 10 of them. Each one takes 8 bytes, which is 2 to the 3. So we're at 2 to the 13 for one iteration. 4 gets us to 2 to the 15. This would be 2 to the 19. This would be 2 to the 24, which is 16 megabytes. So we only allocated 4 megabytes. So let's make this 64, so we have room to spare. And our indices, we only went up to... Oh, that's why we're not seeing more, because I never bumped the indices up, right? I just hard-coded something. Yeah, 24. So what is our actual numbers now? 4, 16, and 32. So how many indices does that need? Three times 4 times 32 times 4 times 8 times 4 times 16 times 32. 1, 2, 3, 4, 5, 6, 25 million indices. Okay. So we'll do 25 million indices. So that's 1 million times 32. And of course, we shouldn't have the... Notice the frame time is really bad, but that might be too many vertices, but it might be that we're doing this in a loop every time, every frame, initializing the indices. So we can just do that at the start. Do we have an int I? We do. So let's do it after that initialization. So that might or might not have been the slowdown. Yeah, okay, now it's a lot more reasonable. We're still not getting any depth on the other two axes. We are drawing them all. Did I change the value? 32, 4, 8, no. 4, 16, 32. Like, obviously, this should all get propagated through as... Oh, I forgot the times 3. Oh, no, because I did it through the calculator. So it's correct. And I just didn't finish my sentence just now. Why are we not getting them along the other axes? Did I screw it up in here? Global invocation, global invocation, global invocation. So that should be scaled properly. It could be because we're not writing them into the correct spot in memory. So we take our workgroup index and we multiply it by the local size. And the workgroup index is workgroup ID dot y, y by x, z by x and y. That seems correct. That seems right to me. But it's only expanding along x, which is kind of implying that we're not expanding along the other axes correctly. Because if we were writing to the wrong location, but expanding the axes correctly, we would get voxels at different heights. So it seems like somehow only x is getting done properly. But we're using global invocation ID.y, global invocation ID.z. Maybe I'm not paying attention. Y is local size y is 4. Dispatch y is 16. So it should be 64 deep, and it's definitely not 64 deep. It's 8 deep. How is it 8 deep? Is that not the x-axis? That's why we have our axis indicators in there. Where's our axis? That's x. That's y. That's z. 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 wide, 8 deep, and 8 tall. So we're getting at least one extra thing of y, but we're not getting all of them. Are we overflowing these? Are we decoding these wrong? Could it be on the renderer side? It's not taking in the data correctly? I don't see how. Could it be the mod 7? No, that's just determining what texture to display. I don't see how this could be wrong. As long as it's writing the correct values in. Like these are extracting correctly. But why do we only get 8 y and 8 z? We're building 4 y and 8 z. So we're definitely getting a y repeat. Workgroup index. What could go wrong? Boy, this is just, you're just saying graphics programming debugging without, when you don't have access to a good debugger. Is there something I'm forgetting? Is there something I'm not doing that I'm forgetting? I've updated the storage to be bigger. Let's make it even bigger to be on the safe side. I've updated all the indices. Let's just make this explicit just in case the macro has some problem. No. We run the dispatch. Okay, let's just dispatch 222. Oh, that's weird. That suggests we are reaching the limit of some resource, like we're writing off the end of the buffer or something. Except it's not just dead ending, it's sloped. Could you possibly get that effect from a regularly... Yeah, you could. Okay. Let's verify by doing this. We still get the same number of them, just they'll be spread out more if what we're hitting is a resource limit. Like they should still have that exact same shape that we saw before. I need to be able to move faster now. No, there are no textures going on here in the layout of the stuff. Yeah, it looks like it's got the same sort of sloped failure stuff. So we're running out of either the indices or the memory. Right, but we did the math and figured out, well, and even now it shouldn't be able to run out because now it's a lot smaller. Now it's, whatever this was, 2 to the 13? No, 32 times 32. So this is 1024. So this is 1024 voxels times 3 slots times 3 face pairs. So we're generating 3,000 face pairs per work group. Each of the 3,000 face pairs uses 8 bytes. So it should only be using 24K to do one work group. And we're asking for 8 work groups. So it should not use very much memory. And the number of indices should be the 3K, 3,000 indices times 8. So there shouldn't be that many indices either. Am I setting... Oh, this is totally wrong now. This is 2 times 2 times 2. But it's still got that weird gap. So something's going wrong. Num-work groups versus work group size. Could be. Work group size is for totally local. So I never need to use work group size because it's baked inside local invocation index. Why did that seemingly not matter? Yeah, exactly. Well, because it's drawing, all the extra ones that this is drawing are all data that's all 0 in the buffer. So it just produces the same, it just is drawing a single triangle or a single quad a gazillion times with the exact same 0 data everywhere. Oh, yeah, we could probably see that if I do that offset again. X plus equals 2, y plus equals 2. There'll probably be one floating face pair at the bottom. Or not. Oh, there would be if I expanded again. So if I draw too many, now we should probably see a floating face pair at the bottom. Or not. Okay, I don't know what's going on. So it's like we're not generating enough, not using all the indices. We're generating more data than we're drawing or something. But this is correct. There's 3 face pairs. Each face pair has 4 vertices. And wait, are we generating 4 vertices? Yeah, we must. I had this working. So yeah, this must be doing it right. Right? Oh, right. No, yeah. You don't generate the indices. The indices are just in the index table. You generate quad pairs. So yeah. So it's for each. So there's 3 quad pairs. For each quad pair, there's 4 indices, but those don't generate yet. Then there are 32 by 4 by 8 voxels times 2 by 2 by 2, plus this extra. So this ought to produce that extra zero, invalid zero data. All right, well, let's look at the invalid zero data by not doing any building. Make sure we can see the invalid zero data. It should be down at the thing. Yep, okay, there it is. Maybe we turn off cull face. So that we can see it more easily. We still can only see one face at a time because that's the whole trick of the thing. Okay, and so now we go back to dispatch, and we're going to see if that guy shows up or not. And he does not. So we're not drawing that extra one. I don't know why we're not. Okay, let's go back to 111. Now we're drawing the extra one. Okay, maybe this math is wrong. I've stepped through it a bunch of times and I'm convinced it's correct, but my cursor was too... Okay, now we see the bad data. If we do this, we shouldn't see the bad data. And if we just add 4 indices, that should be enough to show the bad data. Yep, it is. Okay. So this is correct. This is exactly how many indices are being written. Now we switch it to 222. Dispatch. Oops. There's more data, but it's broken. And we still shouldn't see the thing because it's exactly the right amount of data. And if we go add 4, is that going to now show up or is it still going to be broken? Because this is where we multiplied by 2 in the past and it didn't help. No, it does not show up. So it's like that data isn't zero initialized, or it is, because it's only multiplied by 1 factor of 2. Dispatch compute. So, okay, yep, we get extra x. Now let's do 2 deep. And that works. Now let's do 2 tall. And that works. Okay, let's do 2 deep and 2 tall. And that seems correct. Okay, and then let's do 2 twice as wide. This is where it's going to break now. And it breaks. So it breaks once I change the x. But it was fine if it was just the x. What if it's just the x and y? No, what if it's just the x and z? Because the z seems the suspicious part of what's failing here. If we just do the x and z, it looks like it's fine. It's only that when we step the y as well that it starts failing. As you might have just seen, we are in the compute shader generating a big grid of voxels as a debug, but it's not quite right. There's something going wrong when I try to generate too many. I don't think it can be in the rendering because the rendering is pretty agnostic about all this stuff. 3 times 4 times 32 times 4 times 8 times 2 times 2. It works up to there and breaks after that, which breaking after that is 64K. So it's breaking crossing 64K, probably. But we're not using 16-bit indices anymore. I switched it to 32-bit indices. Or did I? No, I did. If it were still 16-bit indices, that would make perfect sense. That we'd hit that 64K limit. No, I have 32 million indices. No, the SSBO is way larger than is needed. Why would 60... The fact that it's 64K is just super suspicious that there's a 16-bit index thing going on. It's just, it's not 16-bit indices. So I don't know. I mean, I am going through this this interface where it's doing it without being in an index buffer. So maybe there's a bug in the driver path that doesn't support 32-bit indices in this path or something. Right? Like maybe this would just get fixed if I stuck it into a vertex buffer. It just seems weird. Is it not GL unsigned int? No, because it is 32-bit. There are 32-bit. So I know that the declaration of the type is 32-bit. It just seems like it's so suspicious that it's when it crosses 64K. And because of the way that it died off, because there's a factor of 3 in here, so it's not exactly a power of 2, it's going to fail in a kind of a weird spot. And so this seems all consistent with 64K. Do we still have the breakpoint? I think this is all stuff that's so inside the GPU, it's not visible to the API and wouldn't break in the anyway. But we will definitely check. Nope. But it's not an issue. But thank you for pointing that out. So like nothing in here would be 64K boundary based. Offset isn't limited to 32-bit, to 16 bits. Nothing in here should be 16-bit limited. We don't say how big the voxel mesh is. X, Y, and Z are size limited, but that's not a problem. It's just got to be 16-bit indices somehow. I don't see what else it could be. So we will make, I guess, a shader storage buffer. What type buffer type does one use for normal vertex buffers that you're not trying to do compute shader stuff from? Because I think shader storage buffers are a compute shader thing. What's the classic buffer type? Is it just like a buffer? Is it just called a buffer or something? I guess that might be in ZMC where we're doing vertex buffers. Yeah, it's just gen buffer. Well, and it's exactly this, element array buffers. So we can just use that code. So we say glue int index buffer, and we, after we initialize indices, we go gl gen buffers 1 comma ibuff find buffer what is base? Oh, base is the actual data. The size of the data is that times 4. Let's look at GL draw elements. GL draw elements. Does that. So we just say bind that buffer, and we say 0. I think that's ought to work. Set draw. Okay, it's still drawing. So we did get that part at least right. And then dispatch compute 222. Draw elements 222. And yes, that is the issue. 4, 8, 16. So apparently, if you don't do that. Now, what's the vertex buffer thing where you have another level of indirection that you wrap all the vertex buffer pointers inside or something? I'm not doing that either, and I should start doing that too if these things are going to be breaking. What did I just do? 4, 8, 16? For 816. Let me turn on faster movement speed. And in a second, I'll find out how many voxels I'm drawing here. I mean, they're getting far plane clipped. It looks like. Wait, why do they all have height? Oh, that's. What? Why are there some in weird places? Why are some of them double? Why are they all doubled? What? There's something a little weird here going on. Oh, it's just wraparound. It's because the the 256 wraparound, because I'm multiplying them by 3 instead of 2 now, and I was doing the logic of how many can I do based on the multiplying by 2. So that's compute measure. The offset is fine. It's this right here. This should fix that. Yeah, they all look fine. And then we're going to say, go back into the code, and how many vertices are we drawing? And it's this without the 4. Well, it is with the 4. How many quads are we drawing? How many voxels are we drawing? That's this. So this is 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 19. 2 to the 19 is, it's only 500,000. We're only drawing 500,000 voxels. So we can push so let's go to 16 and 32. So we should see a little slowdown now. Oh, and let's push out the far plane. Oh no, the far plane is plenty far out already. It shouldn't. Why did it look to me like I was seeing things disappear to the far plane? Wait, that's not any bigger. It is taller. I don't think I got deeper. But anyway, so as long as I keep it all on the screen, yeah, the frame time is actually starts to slow down a little. A little of that might be OBS. And now, here's the fun one. What does it cost to actually create that mesh every frame? It's just going to compute the exact same data it already had every frame, but oops, I forgot to copy the rest of it. Oh, not even noticeable. Just not noticeable to write that much memory, much data from a compute shader every frame. So yeah, it may well be that the meshifying, well, I mean, this is the easy part of meshifying, right? The whole thing was the very complex design that we were talking about for how to keep utilization high while trying to meshify a more complicated thing. Time to check that in. Let's run this where I equals 0 64 times. Okay, there you go. Now it's started to slow down. Generating that many was bad. Okay. So it's checked in. We go back to our ideas. And we do that. Okay. Now we want the GPU to take CPU supplied 256 by 256 by 256 grid of 32-bit values into this mesh format. How big is that grid? That grid is 2 to the 24 2 to the 26 bytes, 64 megabytes. Okay, that's totally fine. All right, so we go to compute measure, and now we're going to say we have layout standard 430, binding equals 1, buffer, voxel descriptor, voxel shape. It's going to take a uint texture, uint texture side textures. And we're going to need that's an array. It's actually a 256 by 256 array. Let's just do that. And then we're going to have a uint output position. And shared memory coherence, because we're going to start accessing global variables, but not this kind of. So we want that kind. There are special atomic functions that can be applied to variables in storage blocks. They operate only on uints. Atomic add. So what we want to do is we're going to do this in a dumb way. We're going to have every cell in this 256 by 256 by 256 grid is going to run, for every one of these, we're going to run a little job. So we're going to run whatever that was, 16 million or 64 million jobs. 16 million. So we're going to run 16 million little jobs. And all the job is going to do is say, do I make a single voxel? So we're going to do a layout of 64 is what, 4 times 4 times 4? So sure, let's do that kind of coherence. Mesh index into mesh data. And we're going to say, it's the same thing that we need to do. We use the global invocation X, Y, and Z. So uvec3 pods equals gl global invocation ID. And then we say uint text equals side textures of pos, and if text does not equal 0x. No, that's the textures. F. Okay. If it's not that flag, so that's our empty flag. I'd rather use 0 as our empty. So let's always set high bits on the textures that get discarded. Oh no, right, they're only 5 bits textures. Right, so we set the high bits on the whole thing if it's not empty. Right, okay, that works. So if text is not 0, then we make the voxel. We're just going to, we're not going to look at the neighbors. We're just going to go ahead and output solid data. and the textures need to get unpacked. So it's UVec bit extract, bit field extract, tech 5 bits offset 0, tech 5 bits at offset 10, bit field extract 5 bits at offset 20. 5 bits at offset 5, at offset 15, at offset 25. Sorry for covering up. Oh, no, that didn't cover up anything. Right, that's great. That works. Yes, the GPUs are so amazing that it's like, that was that thing about that I was able to generate that much data so fast. Okay, so if we run all this data and there's all this open space, and if there is any voxel in there, all the lanes are going to sit here and do nothing while this is running. But if a lot of them have stuff, then it'll be reasonably efficient. And if all of them are empty, it won't do any work at all. It'll get past this pretty fast. This may not be the fastest way to do it because it does so little work if there's nothing to do, that maybe it's faster to iterative, like, I could have a loop here, and we'll look at that. We'll get to that. Or maybe we won't. Maybe we'll wait. We'll do that as part of the full thing and not do it here. So let's not offset for debugging purposes anymore. What am I forgetting? Do I have to do something else, or is that it? Is that enough? Oh yeah, now I need to compute the slots. So the way the slots need to work, we need ballot arb. So who has ballot arb? I think somebody in Voxel has a ballot arb. Maybe commented out. Yeah. And then ballot. Yeah, I'll have to look at the thing. GL arb shader ballot. And if we switch down to only 32, then we can just work at 32-bit numbers and we don't have to deal with this, because you can't do like pop count on 64-bit. You have to do a pop count on each of the 32-bit fields, so it'll just be a little simpler if we don't do that for now. So what we actually want to do here is we want to say bool what we want to say int face count equals 0. If text does not equal 0, face count is 3. Because in the future we'll figure out how many we actually need and come back. So now to ballot arb, we call ballot arb with a bool. So uint all low equals ballot arb boolean. So the boolean is face count and 1, the low bit, does not equal 0. Uint all high equals ballot arb face count and 2 does not equal 0. So now the high bits all contribute 2 to the face count, the low bits all contribute 1 to the face count. So uint total faces equals all low pop count. What is it called? What is pop count called in OpenGL? OpenGL population count integer. Bit count. The number of step bits for all low is bit count of all low, and that's times 1 plus bit count of all high times 2. Okay. Oops, times 2. So now, if lane is 0, so if, is there something special in ballot arb to do if lane is 0? It's the same as, like they have a hack using read first invocation or something, but I'm not sure why you need to use it. Yeah, subgroup invocation arb. I'm not clear why subgroup invocation arb is different from. Oh, it's different because you can have multiple subgroups per thing. Yeah, right. So we want if GL subgroup invocation arb is 0. So the very first, only the first one is going to do this atomic add. So now where's this thing with my atomic adds? So we say uint index equals atomic add index into mesh data. Total faces times 4. No, just total faces. Because we're measuring face pairs. We're not measuring indices. So this is where to write. This is where this subgroup starts writing in this mesh. And we need to broadcast that back to everybody. Which I think there's a way to do. Turns the value from a given invocation index to all active invocations in the subgroup. Read invocation arb. So we do uint index equals 0. Index is that. Read invocation arb of index of 0. So now, after this little stutter step, we've done the atomic add, and now all of them have it. I believe. I'm not sure I've ever done this. So now we're very close to knowing what slot each one needs to write it into. I guess what I should have done is I should do this logic with the old let's see if I can undo back to the thing that was working. I should, instead of manually computing the slots like I do here, I should try using this logic to compute where to write them. Oh, no, I didn't undo far enough. It wouldn't let me undo far enough. Okay. We have to bring up the saved thing from the repository. Equal repository purge games CMC2. And then we want data shaders, voxel, no, compute measure. So here's the old one. So take the old one, put it at the top. Then take this new logic, put it in here. We don't need worker index. And face count is just always going to be 3 because they're all generating always. Okay. So the other lanes, the total faces is identical for all of them. Okay, yeah. But now we want to do that, the prefix count, what is it called? The prefix sum style thing, but we don't actually have to do the prefix sum. What we need to do is we mask out so let's see, twiddle1 is all ones. And then we want 0 at the bottom bits. The thing is, you can't shift by 32. That's the thing. So how do we do this? We want the pattern all ones with a 0 at the bottom, then all ones with 2 zeros at the bottom, all ones with 3 zeros at the bottom, and then all zeros at the end. Right, so we can just do that with ones. So we want 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. How do we get that? This is a thing that Fabian has. It's some simple trick that I never remember what it is. If we just want 1, 1, and we're at 0. So we take all ones, and we shift right by 31 minus. Let's put this in a variable. Main equals. So if we take 31 minus lane, then that ends up being 31 when lane is 0. And we shift that out, and we'll get a single 1 bit at the bottom. And then we invert that. There's got to be a better way to do this. So we're trying to ignore we're trying to zero out the bits that are from, oh no, we want to zero out the bits that are higher, not the bits that are lower. Oh, dang it. Okay, we want to generate this pattern. We want this function. What is this function? Is it just that? No, because that doesn't shift out enough. But we can't shift by 32. So we can't do 32 minus lane. So is this just one shift left lane minus 1? Is that what this one is? So 1 shift left is 1 minus 1 is 0. 1 shift left, that was 1 shift left 0. 1 shift left 1 is 2 minus 1 is 1. 1 shift left 3, yeah, okay, so I think it's just that. I covered up my chat. Okay, so I think that's right. So now, at this point, we can say that all of the lanes previous to us will produce. So let's actually just name this something else. Uint prev low, uint prev high equals all low and that, all high and that. Previous faces is prev low times 1 plus prev low times 2. So now our slot is the global index plus all the previous faces. Voila. We'll have some compiler errors. Oh, didn't enable it. Oh, I put it in the wrong file? Where did I put it? Oh, it's in this. I have to cast. Right, because I didn't want to deal with the 64 bits, so I made these only need 32 bits. See, this is the reason I didn't want to do 64 bits is because this, you have to do a 64-bit version of this that's shifting across 64 bits. So it's possible to do, you just have to write some code. And so I'm just like, let's just only do 32 bits. Index into mesh data. Oh, that's also down here. I mean, this won't run because I haven't set up these buffers, but just want to get the shader compiling. Undefined subgroup invocation arb. Is it like, did I get the capitalization wrong? Subgroup invocation arb. Oh, it's GL subgroup invocation. No, GL underscore subgroup. Yeah. Chat figures it out, but I don't look at it fast enough. Okay, so that's of course not going to work because we haven't actually hooked it up. Let's make sure we're not doing the we're not recomputing the things anymore. I think I if-zeroed it. It was really slow, but that may be because the data was just bogus. Yeah, as if zeroed it. Okay. So now we need to set up that that count. What is that? Needs a different binding. Right, because this one needs a different binding is what it is. This is a 0. Oh. Oh, here it is. Okay. Yeah, we don't need 1 and 2. So, and can't be both called voxel shape. Mesh index binding equals 2. So yeah, I've never done this atomic add prefix sum kind of thing before, but I know the theory, and I think this will work fine. So Indexing mesh data is binding to. Okay, so we just need a little tiny glue int mesh counter count. Mesh count equals create shader storage. Let's make it like 1,000 bytes for future usage. And we want to avoid, I wonder if it's important to avoid false sharing. So let's make it 65536 because we're going to put a couple counts in there someday. And then we need to update it. Where do we do our update? We don't anymore because it's being built by the thing. So update buffer. Mesh count at offset 0, length 4, 0. Length 0 equals 0. So we initialize the count, and then we'll call meshify. No way that's right. No, that's not right. Okay. Now, if it's fails, we should have them all generating data in the early slots, and there should still be a little bit of data somewhere. But yeah, no, we're just getting the 0 data. So it's not managing to write the data at all or something. It was displaying 1 quad, but it was generating 0 quads, I think. Because that's the quad that it displays if there's a 0 in the buffer. So I think it was displaying 1,000,000 quads, but they were all zeros. I think. The ×2 is to make the voxels not adjacent to each other, because if they were all adjacent to each other, you wouldn't be able to see the interior at all. I have a feeling I'm going to do a voxel Saturday this week, so that I can start doing the command buffer stuff, because this has taken, I had lots of extra time debugging stuff here. The problem is like getting the things working, right? Like I hadn't done texture arrays before, so it was a lot of getting stuff working that was really slow to debug. Once everything is kind of in place, I know how to write to memory, I know how to do the atomic adds and all that stuff. Then I'll just be doing more normal coding. It'll still be a little tricky to debug because it's on the GPU and I don't have good debugging, but it won't be as bad as this stuff. So I was kind of already picturing that I'd be going at that pace. Yeah, so people are agreeing. So yeah, so I just feel like I really kind of want to write that command list stuff, and so I got to get this done first. And I mean, since 8, so it's 5 hours, so I could go for another 3 hours probably. So we could get the commands buffer stuff done depending on how long it takes me to figure this out. So what could be going wrong here? So the atomic add could be going wrong. So that's an interesting thing. Let's have index be computed by GL global invocation. It's from code. It's the old code. What happened to that text box that I had with the old code? Here it is. So where does each subgroup start working? It's going to be sort of that. Oh, this still has this, which ain't going to work. Because it can only work within a subgroup. So we have to switch to that. Which means this is going to be 442. I don't think that's going to make a difference. Especially if I'm in the middle of typing in the thing. Don't think that's going to matter, but there's two things going on in here, so we can process them separately. One thing that's going on is we're using an atomic to figure out where the subgroup should start writing. And the second thing we're doing is where within the subgroup should we start writing. So let's ignore the atomic and do unit group equals GL global invocation id.x plus GL global invocation id. Do I not have this in here? Oh, it's this one. So the group is this. So then we say the base slot is the workgroup index times what? Well, there's 32 voxels in it, and each one generates 3 face pairs. So I think it's that. And then we'll see if we do that, do these manage to do it correct. Now we can just do slot. So let's do this as well. Slot equals index plus, so previous faces is the lane times 3 is what it ought to actually work out to. So we don't do any communication, we just try to figure out what the communication should be computing. Okay, great. And let's dispatch it a little bit bigger, since these are now small. Where's the dispatch? There it is. So let's push this one up to 16 as well. Okay. So now we're doing the expected computation, and it's all working. So now we can debug the 2 steps separately. So let's try the atomic and broadcasting the atomic across. That don't work. A few little isolated things. Okay, so let's not try to look at that. Let's look at this. Are we communicating the previous faces correctly? I think so. I think this looks right. There's some isolated things. Not quite right. We need to do a barrier, maybe? The atomics shouldn't need a barrier. I mean, we can just stick some in. It shouldn't matter. I don't think it's necessary in this case. Yeah. We're doing something wrong somewhere. As we get later work groups going. The later work groups are having problems. Are these overlapped? Am I missing? Did I compute this wrong? The work group has 4 times 4 times 2, 16, 32. And it's going to generate 3 face pairs. So index should be the work group index times, so is the work group index correct? Yeah, because I copy pasted that. Shouldn't preload and pre-high be based on the pop count of those values? Yes. So that is why that part is wrong. Bit count. Bit count. All right, so let's see if that fixes this part. Oh, right, yeah. Thank you for catching that. Yes. Okay, so that part is working, maybe. It seems to be working. So then it's just this part that's not working. Unless it's magically working how I put in barriers. No. Still totally broken. There is no global index. Yes, I'm manually computing the index. OpenGL is asymmetric and only has the local index. It's not the global index, it's the workgroup index, which is why it's called workgroup index. Preflow appears twice on that bit count line. Oh, yeah. I wonder why it worked. Oh, it worked because in this case we're doing 3. Everything is always 3. Because the next step to try is to only produce some faces on some things. Okay, so this communication is working. I mean, working insofar as all it transmits is all ones, but it seems to be working, maybe. But then the atomic add, and then the sharing that atomic add across is not working at all. And I don't think I need to barrier, because I don't need these all to run simultaneously. They shouldn't need to. Yeah, that's because I'm overwriting index there. This is the broken path. So why is this broken? Yeah, maybe, I don't know. I don't think it matters. None of this should need the barrier because we're doing atomic adds. The read invocation arb is just within a subgroup, so it's implicitly synchronized because they're all just SIMD lanes. A subgroup is just a collection of SIMD lanes. In the lane equals 0 on the read. I'm pretty sure none of these barriers are needed because atomic forces atomic synchronization and everything else is within the subgroup and doesn't need any synchronization. Plus, we know that all that's being transmitted across are all ones anyway. So it's really just the atomic. The atomic isn't working. Do I have to... No, I don't want it to be shared because that's a special thing. Do I have to attach the word atomic to it or something to make sure it knows it's allowed to take atomic operations? There's a volatile qualifier, but I think if you use atomics, it's supposed to know. OpenGL atomic shader storage buffer volatile. Let's look at the old ARB shader storage buffer, which may have more details. or it may not have atomics in it. I don't know. Atomics might have been a separate thing. Yeah, I don't care about this part of the synchronization. Memory access is using shader buffer variables issued after the barrier. Where the fuck do you... Yeah, what this is saying it doesn't affect atomics interacting with themselves, because atomics are atomic. They shouldn't need anything else. But I could be wrong. I could be misunderstanding. Like, none of these things have examples of the atomics being used, so I don't actually know. Okay, here. When ACOS GL commands triggers... Okay, so... And subsequent GL commands read the memory written, which we're not doing. It's all private to within that one compute shader. I need to find somebody else doing this. OpenGL atomic add Vulkan man pages atomic add example. Maybe it involves putting in a barrier, but it's... But no, here the barrier seems to be for reading. The whole thing about atomic add is it returns a value, and in the example I'm looking at, he doesn't look at the return value. He does a synchronization, and then it's looking for the final value after everyone's done it, which I don't care about. OpenGL increment counter with atomic add. Let's say, try that. Unfortunately, I have a thing called an atomic counter. Increment index with atomic add. Yeah, people just do atomic adds without barriers, which is what it should be. Are you sure that total faces is correct? Okay, that's a valid point. It should be because it's the same math that we're doing down here, but let's hard code it. There's 32 neighbors with 32. So we'll hard code that. It could also be the read invocation arb part is busted. Right, so either the atomic is going wrong, or sharing it across the lanes is going wrong. But I'm pretty sure should just be able to assign what? No, the read invocation arb is, let's comment this code. There we go. That's what this code is doing. It seemed like it should be really easy to do from all the stuff I've read about it. But I can't find any actual discussions that show code. All the discussions imply you shouldn't need barriers. You need a barrier to read. So at the end, when you're done, the index tells you, the final value of the atomic tells you how many faces total you put in, which will then tell you how many faces you need to draw when you draw. So when you go to draw, you'll need to have done a barrier to make sure that the total count is updated to the final value. The fact that they're so randomly sparse is so weird. Like, if they're writing it into the wrong place and getting overdrawn, you'd still think you'd get a little bit of a distribution. Well, conceptually, you can say that this is a different variable, but it's computing the same thing. So this is right, like when you broadcast the index value back all to to lanes, it's still the index value. It's just this value is different for all lanes at this stage, but only lane 0 gets broadcast. So whatever value is in index for lane 0 gets broadcast. The output of that broadcast is now the same value in all lanes, which all lanes now write to index. Read invocation arb is private to this SIMD sub thread, so it requires no synchronization. It's part of this ballot arbs thing. Ballot arb is a system for letting you communicate across SIMD lanes, because normally all of those SIMD lanes operate totally independently. And read invocation arb is part of that, and it's just to let you broadcast across all the SIMD lanes. And the whole point of SIMD is implicitly synchronized because it's just all running in lockstep. Because it's all a single instruction, I mean. Right. This is just equivalent to some SIMD instruction that is like, I don't know what they're called, but it's like, select. Let's say we gave them a different name. I don't know. I don't have a good name for what it is, because it is the same thing in all of them. But let's say it was this, right? This is just like a SIMD instruction that's like, maybe I should just find what the equivalent is for. So like in SSE, we probably know SIMD stuff anyway, or something. Probably a lot of you don't know it, so it wouldn't be helpful. If you think of the SIMD as being a struct XYZW, then all that the instruction right there is index dot y equals index dot x, index dot z equals index dot x, index dot w equals index dot x. That's all that instruction is doing if what this was for wide SIMD. Index C. So I don't think it's the broadcast. If it were the broadcast, if it were this, at least the 0th one would be correct, and you would see a regular pattern of correct voxels across the thing. All the lanes are synchronized in a single work group, in a single subgroup, which is the same as our work groups for this. They're all always in sync. All the lanes are in sync. All of the independent work groups can run through this code at different times, and that is why the atomic add has to exist to allow the synchronization across the work groups. But within a single work group, it's a single subgroup, everything runs in lockstep. There's no need for synchronization. So the only thing that is not in lockstep is the atomic add that's communicating across work groups, and that's an atomic operation, so it shouldn't need a barrier. That's why there's no need for barriers logically in this code. And we would see something totally different if the problem was barriers. We would see something, I don't know what, but we would see more data being drawn. Like, I don't know. Like, it's weird that we don't get a full batch of... Oh, maybe we do, because the batches are now only 4x4x2. I forgot that. So that's probably what these are, is... yeah, it is. Oh, but only one... Am I not multiplying by 3 somewhere? Is there any chance that lane 0 might not be active? That is a problem with this code, but in the particular thing that I'm running, lane 0 is always active. Because there are no ifs here that could cause lane 0 to stop running. But that is the end issue with this strategy. Like what you need to do is find who is the first. The correct way to do that is you use ballot arb of true, and that will return you a bit mask of all the active lanes. And then you can say who's the lowest lane that's active and do it all there. I'm just using lane 0 because I know they're all going to be active. That's just how this works. When you haven't done any ifs, you always get a full thing. But it looked like I'm missing a 3 somewhere. But I mean, it's all based on that. Face count is 3. And then we do the face counts for the previous. Like if I do that, is that going to change that? It shouldn't, because we established that. Yeah. Yeah, that's not what's causing it. But that's weird, because why are those affected? Once you're starting to write some of those, why do only some get written and not the others? Because they're packed in memory. They're packed in memory adjacent. So if they were like weirdly overlapping each other, they shouldn't be spaced like that. That doesn't make any sense. Yeah, this is weird. Why would these not... Why are these not full voxels? I can't see how that happens. Okay, if we do this, are we still everything working right? Yeah. Yeah, it's all fine. I gotta remember I can hot load. I think I can hot load. Did I put a hot loading in? Control L. Oh, I can't hot load because it only runs at the beginning. Just feels like they're all running to the same memory location or something. Yeah, I just don't understand how within a subgroup it's doing that. How is it that each lane is writing out one face correctly but not the other two? Like, if all that's wrong is that the starting point for where the subgroup should write, which is what the atomic is computing, if that's wrong, it's shifted somewhere else in memory, and it still writes out all the voxels correctly, and then someone else comes in and draws over them, or something like that, you wouldn't get this weird pattern where you're only getting one of the faces. It just doesn't seem right. Like, it would make way more sense if, like, all the missing stuff can be explained by some things are for some reason, somehow the atomic logic is wrong, and a bunch of things are all generating into the same slots. That explains why that stuff is missing. It doesn't explain why you only see one side of a group. Something else is overwriting the other faces, right? But it's this sparse pattern. It has to be overwriting two of them, but not overwriting the third. And I don't see how you do that, because everything is always writing 3 continuous. There's nobody stepping by any amount, so I don't know how you get that pattern. It just doesn't make any sense to me. Is there another way that I can do this? I guess not use atomic adds. Can I use barrier? I still need the atomics because they need to independently read and write that data without conflicting. Okay, what happens if I just don't do it atomically? uint val equals index into mesh data, index c equals val, index into mesh data equals val plus 3 times 32. How, in what way does this break? It's just totally broken. Why does not even the 0th one work? Oh, because they just all overwrite the same thing. But yeah, that's still that same pattern. Okay, now what if I say that this is, I don't know, volatile? Coherent. When communicating between shader invocations for different render commands, memory bear should be used. Okay, coherence of memory accesses. Do I need to say coherent? Yeah, I don't want barrier. Barrier causes things to synchronize, and I don't want them to synchronize. Memory barrier, maybe. Maybe I want a memory barrier. I don't think so, but I'll try it. No, doesn't make any difference. Okay. Did I change this to volatile? Yeah, I changed it to volatile. What if it's coherent? I mean, there's still a race condition here. Yeah, it's not making any difference. Not making any difference at all. What do you mean by atomic underscore int? No, that's atomic counters. That's a different thing. If you look at shared storage buffer, there's a section on atomics, and they just work, right? Because the compiler sees that you're calling an atomic add. Let's put it this way. If it was required to be atomic int, then when you called atomic add, it would give you an error. You would hope. But I do know explicitly I was looking for that. Atomic counters are a separate thing. You can't step through GPU. I mean, I don't know what modern render doc has, and I can't use it. It's not CPU readable. If I were reading it from the CPU, I've mentioned this before, eventually this becomes the count of the number of faces to draw, and then when you go to draw it, you do need something to access it. But you do that from the API side. But I'm not currently accessing it from the CPU side, except to initialize it to 0 at the beginning, which I guess maybe I need to do it there. I can't imagine it would result in this kind of behavior, but who knows? GL memory barrier, something like that. I may not have it in my platform. Yeah, it's GL memory barrier. It has a bit field pattern. Okay. Oh, I do have it. Okay. It's just not auto-completing. I think it's this one. Oh, or this one. We'll just do both to be on the safe side. But I mean, all of this is just the initialization to 0. So I don't. Maybe. I shouldn't prejudge. Maybe it is that. I've never done any of this stuff, so it's totally possible that it's uninitialized memory, and that does need to go through, and somehow that could affect them all. No, it doesn't. It makes no difference. But it's good thing to check. No, it's fine. Like, if I had a plan of attack, or I was trying to juggle stuff in my memory, it would be bad for me to be trying to read random suggestions. But since I have no idea what's going wrong, and nothing to make a mental model about, God, I hate when I'm just going to get stuck for 2 hours on some random thing. I can't find any sample code that does it on the internet, even though I know it must exist. I'm just not coming up with the right search terms. OpenGL, atomic add, prefix. Let's do a prefix on. Let's see if somebody out there is doing a prefix on. Atomic buffer appending. How about that? Atomic buffer append, because that's what we're doing. We're appending data onto the end of our buffer. But not using atomic counters. Don't use atomic counters. Nobody had sample code. They're just talking about it. Atomic counter. Somebody's using an atomic counter. Drakenbart, I don't know how to test what you're asking. Oh, I see. I do understand what you're saying. I can do this calculation here. I can do that. And the answer is yes, it works correctly. So yes, as expected, the broadcast, because the broadcast is the simplest freaking thing in this code. So yes, the broadcast is working correctly. But sure, like at this point, there's so much, I don't know what's going on that, yeah, it's worth testing. I mean, we know the lanes don't have the correct number, so I'm not sure what there is to validate. So here's one that's using atomic counter, which is the old, not recommended anymore way. I guess I could try it using atomic counters. It just doesn't let me do this fast add thing with the atomic add. I started with basic, BASIC. So this is all an optimization so that each lane doesn't do its own atomic add. I could have every lane do its own atomic add and see what happens, but I can't see how that's going to help because we know that the broadcast is working and we're hard coding in the faces. So it's not writing out triangles, it's writing out the faces of the cubes. There's 32 cubes. Each one has 3 faces. I guess I might as well try the naive thing here. So naive thing is if 0 else and if slot equals atomic add index into mesh data 3. I can't imagine this working when the other stuff doesn't work. Wait, where did I did an if 0 around this whole thing. Where does that if 0 end? Oh, it's this. Okay. Yeah. Okay. Oh, well, yeah. UH slot. No, and now it's even more random. Yeah. Have one incomplete cube. And some uninitialized data. Ooh, it's real slow here. So all the, it's like all of, oh, it's all, because it's all uninitialized data, so it's all rendering there. Yeah. And since it's rendering everything to the same spot, it actually, the fragment shader starts to slow down if it gets large on screen. So yeah, that's basically just as bad. And the question is why that doesn't work. And I just can't find anybody doing example code with it. I know I've seen code that does this kind of thing in general. Nope, these are atomic counters. OpenGL atomic counter. Let me make sure I'm not confused about this. Well, it says I should use atomic counters if I can use them, and I guess I can use them. This is your atomic unit thing. So I guess I can try it. Why would you make them be uniforms? What does that do? Oh, I see. Yeah, I tried the normal shared int thing for this thing. I don't want to reiterate it again. Yeah, for this. I don't want to reiterate through that again for testing that case. Let's go ahead and try the atomic counter. Since it does say, I thought that was a thing that had been I thought that was something that had been deprecated, but apparently not. Okay, atomic counter. Atomic counter add. Zero, zero, one. Okay. Index C equals atomic counter add. Index into mesh data 3 times 32. Well, it'll give me an error if that's the case. I never said, I never put the type in. Oh, I deleted it. It was atomic to my nipple. It's not called atomic add, it's called atomic counter add. Wait, where did you see atomic add? This is if def out. Oh, no, I still have that big if def around the whole thing. Let's get rid of that. Or actually, we should test that. Yep, okay, it requires. So we should change that one to this. Unit slot equals atomic counter add. Mesh data 3. And we'll ask for 4.6. And see if we can get it or not. It's in main. Oh, version 460. Okay, so first of all, it should be a little slow to hit that many atomics, shouldn't it? But also, maybe like atomic counter is something that has. I think I've actually read somewhere that maybe it's an atomic counter, or maybe it's just even the other atomic, that there some hardware has a fast path for this, where if all the lanes try to hit an atomic at the same time, an atomic add, it internally does all the stuff that I was just doing. I think I've seen that or heard that. So right now we're just doing this. And it didn't, it produced what? Nothing? Produced no data at all that we can find. So let's retire this path and go back to the smart path. And we got the exact same behavior with the atomic counter. Oh, wait. That has all of its sides. But it's like, that's like the last one. That's like there was no atomics. That suspiciously makes me think that's like the last block. They're just all writing to the same block. They're all adding 0. Instead of all adding 3 times 32. Or equivalently, they're just not getting incremented at all. Is there other stuff I have to do? Oh, you have to do this. Right. So we don't have one. So it's not doing... Oh, I wonder if it was something like that for the shared storage buffer. If I'm not binding it correctly. So, where's the 0? All right, it's creating shader storage, so I'll have to create shader storage. Was I ever bound? Did I never bind that at the where we're calling the draw? Is that the problem? Or did I actually bind it? I don't think I ever bound it. That would be why. Oh. I just forgot to do that this whole time, and who knows what any of that was doing. Maybe I deleted my breakpoint again. No, my breakpoint is still there. All right, well, we'll stick with the counter for now. Especially if that's actually recommended. Oh, no, because I don't want to use 4.6. Yeah. But we'll stick for it for now. Mesh count equals buffer. And get rid of this one. And see if we can get it working at this point. Oh, yeah. I may not even be in my my files because it's new enough. Grep gl atomic counter buffer start h. No, I do have it. Define gl atomic counter buffer 0x92c0. Because I've left the code currently in the atomic counter state, it's just faster to try it than to go back to the other one. Okay, we'll go back to the other one. Wait, I still have more to do here. Oh no, I was looking at the draw call. I wasn't looking at the creation. Where do we do the dispatch commute? Well, it's okay, so it's still not happening. Find buffer base. I put it in the wrong spot. There. Dispatch. Where's the dispatch? Dispatch. Is there a 1? Is there a binding for 1 that I'm also missing? Binding to binding 0. No, okay. So that should be back to that. I should have left in the simple path where I just do the atomic add for slot. Just disable. This will just compute the wrong thing, but we're going to ignore it because down here we'll do slot equals atomic add. Where's the code? Index into mesh data. Oh, okay. Yeah, now this is a shader storage buffer. What should be into? Ah, that should be. Okay. Now, is that doing the atomics, or did I... Yeah, it's very hard for the atomics to work if you don't give them any memory to work with. So that's me hard-coding it. Not hard-coding. That's me letting the GPU be clever and avoid needing to do all the atomics. And maybe I can rely on that. I don't know. Let's put this back to 4.2.0 or 4.3.0, whatever it was. And this goes back to 4.3. I typoed something into the shader. Or it needs 4.30. Okay. So that's all still fine. Oh, so dumb. So dumb. Like, probably every single version of that works that I tried if it just actually has memory to work with. So you went previous faces. Let's actually propagate previous faces in instead of hard coding that. Yep, okay, that looks good. Now let's reunification arb. Now we want to do this atomic add, and oh, that didn't make any difference because we weren't using it. We do that. Looks like it works. Looks like that logic was all perfectly fine, and I just never hooked up the memory. So dumb. Now, I could be wrong. I could be running some other code. So let's kill everything that I'm not running so that we can look at it and actually see what's running. Okay, we come in here, we compute how many faces. Okay, so let's do a thing where each one only does some faces. What's a way to get a random number? I guess we hash it. So we can take, we need that work group again. Undo. Okay, here's work group. And then redo. Okay. So we want a unique ID for each lane. So we can take work group index times 65536 plus GL local invocation index. So unit hash equals that. So now let's take hash and, you know, I don't know, multiply it by some number. I'm not going to bother looking up a real hash function. XOR equals hash shift right 16 hash XOR equals hash shift right 11. Okay, and then let's say that face count equals hash and 3. And if face count is less than 1, face count equals 1. Now, we have to actually propagate that through. Int face count if face count greater than 0, greater than 1, greater than 2, make voxel face count. Maybe I've forgotten to do something. 49. Yeah. Oops. Oh, I'm in overwrite mode. No wonder. I continued typing while I was looking at the chat. Oh, I updated the wrong. I updated the if 0 to 1. So yeah, it was another dumb thing. Once again, just some dumb thing that then maybe take an hour to figure it out. Okay, that looks plausible. We shouldn't be getting that. Because that's uninitialized memory. Oh, yeah, because we're drawing the wrong number of indices. Because we're still drawing all the indices. Because we don't read back the number that got written. So yeah, I think that looks plausible. We don't really know what it would look like. Okay, here, we can do this. We will say, if you're on the interior of the thing, you only get 1, and otherwise you get 3. So, we have to hard code the size. I'm not going to try to do it correctly. So what's the dispatch? 16, 16, 32. So it's 16 times 4, 64. 16, 16, 4, 64. Okay. So it's a 64 by 64 by 64 cube. So, so we'll do the hash one, and then we'll just overwrite it. So we say if GL global invocation id.x equals 0, or GL global invocation id.y equals 0, or GL global invocation id.z z equals 0, or if they equal 63, then they're on the exterior. And we say face count equals 3, else face count equals 1. Okay, so in theory, the interior should be all one-sided, and it is. And you can see through to the exterior, and you can see the exteriors are all solid. Okay, so I think that's working. Which makes sense, because that freaking, all the logic said that should have worked all along. Oh, is there one side of this that's wrong? The positive side of X? Yeah. The positive side of X is wrong, and so somewhere in here, about halfway through, is a solid, or should be some solid bricks. Here they are. Here's the solid bricks stuck in the middle, which is good. That's a good broken test to do. So, and out of curiosity, if we do it the other way, I assume it's impossible to tell what's going on. It's not going to be as obvious. Well, it's not that bad. You can see that the thing is, it's always just the x-axis facing everywhere. Okay, so I think that's working. We could try to be sure it's working by reading out the index into mesh data as the index count and make sure it ended up at the right value. But I don't think I'm going to bother. I'm going to CMirror it though. Let's do this. Let's say face mask. Let's say face mask uint. Let's say if you're at 0 or 63. No, actually, yeah, it will be that. Okay. If you're at 0 or 63, then face mask or equals 1u. If this is at 0 or 63, face mask or equals 2u. If face mask or equals 4u, base count equals bit count of face mask. Then we pass face mask in to here. And these now say uint face mask. Because we might actually use it this way. I don't know for sure, but it's possible. Face mask and 1u does not equal 0. Yeah, that's correct. That's what we expect. And so now if we don't multiply them by 2, we'll get a nice solid 1. So yeah, now we get a solid block and the interior is empty. And because of the way the voxels are done in pairs double-sided, you see an interior as well. All right. And again, there's reasons why this is actually totally bogus and could imply that it's doing something totally wrong. But I would expect some things to be missing at least. So, all right. So I believe all of that's correct. I'll go ahead and check it in again, even though I just checked it in, just to get that face mask stuff. Because the next step is to merge it back with what I started writing. I think I'm not going to take a break. Did we revert the total face hardcode? I sure hope so. I mean, we didn't revert the total face hardcode in the C code because I don't want to deal with reading it back. So yeah, I think probably what atomic counter is exactly this. It's like, hey, let's make a thing that's efficient to do atomics from multiple lanes at the same time by under the hood rewrite the code, rewrite exactly this code probably. That would be my guess. I haven't actually read a clear pitch for what it is. Like probably the thing to do is find the extension and see what the point of the extension is. Like, what is the reason for this when you already have atomic add? Like, they don't really give a rationale for it. It seems redundant to atomic add. Do you have it in the questions? It's very unclear. I don't understand what this provides over atomics. Unless it's the thing I was just talking about. Yeah, I don't understand what this is for. I talked, I think in yesterday's stream, about the fact that you can't actually merge faces to bigger faces. That introduces something that's called cracking. If you put in code to avoid cracking, you can. But every YouTube video I've seen where people talk about doing it never mention cracking. They're advising people to do a thing that won't work. The 0 times total faces is still there. Oh, yeah. So it is. So that's exactly the kind of bug I was saying means it might not be doing anything. It might be wrong, but okay, good. Fortunately, it's still working. That was just leaving a lot of empty space for all of the things. And now if I queried back the value of it, it probably would be correct. It would probably be the number we would expect. Oh, and that, now I know what that number is. When it was pseudo-random, I didn't know what it is, but now I know what it is, right? It's the, so I can actually only draw as many as we think it is. And if there are gaps, basically we shouldn't see the 0, 0 thing get drawn anymore. So what we expect are 4 indices times how many faces? There's 6 sides to the cube, and each one has 64 by 64 faces, I think. So if I did the math right, we shouldn't see a dummy one here. We don't. And they should all be present. They are all present. Okay, good. Thank you for pointing that out, because now we have a lot more confidence that this is correct. My guess is that atomic counter is to avoid you having to do this logic, but the fact they just don't say that anywhere confuses me. I don't know. I don't know what the... I don't care. I'm not going to do atomic counters. I'm going to do this. Like, it would totally make sense that they're like, this is way silly for people to have to do themselves. Let's just have the GPU have hardware that merges the things. Which they may have, because maybe we can just run it normally, even without the atomic counter and just with an atomic add. I feel like I've seen that they do have that fast path on GPUs. And then they're like, well, let's make an atomic counter that like makes explicit that we have that fast path. That would kind of make sense, but that's not what they say, so I'm so confused. Atomic counter is the problem is that atomic counter is new. It requires 4.6, and I'm at 4.3. So they added it, even though atomics already existed. So it just doesn't make sense to me. I guess we could Google rationale OpenGL atomic counter. When atomic add exists. I don't understand the point of atomic operations. No, that's something else. Atomic counter versus atomic operations. No, you don't need atomics. Like, is it just syntactic sugar for atomic adds? It seems so weird to me. I cannot figure out. The SSBO came after atomic counter buffers, but I don't think that's true because of that version thing that we were talking about. I don't know. I guess that's true, but I don't understand then why that's true. Yeah, I saw that they recommended ACB over SSBO. Okay, yeah. ACBs are internally implemented as SSBO, so they're just redundant. So why would you ever want to use ACBs? I don't know. That's dumb. Okay, but thank you for establishing there's no performance difference. That's useful to know. And since atomic counters require a higher version, I'm not going to do it. Seamer update again just to make sure I didn't miss it. Okay. So now we've got all that working. So now what we do is we take all this code. Okay, well, we write this out to compute measure test, and then we go back to compute measure, and we say we want all this logic but with this new thing that we had started writing. What was the new thing that we had started writing? We never actually wrote anything other than this, I think. Oh, no, we did have some stuff here. There was a little bit of stuff here. Okay. So let's copy all this. Okay, so first we decide, do we make a voxel? And we do that by doing these three things and that. Then we're going to use the existing code rather than this version in case we fix something. And then we go to this. So find okay, at this point we have valid data here. Boom, 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 boom. So then we say, if text is not equal 0, do that and pass in the face mask, which for now is 07. It's 7. You. Okay, I think that's probably about right. So this takes the big 256 by 256 by 256 thing and runs each one independently. Should I be a voxel? This is going to be a lot more steps than the old code was. And we want to optimize out if total faces equals 0, return. So we don't want to do the atomic add of a 0. Which again might be optimized out anyway, but we can just stop if none of them have a faces. Okay, so maybe this code is right, maybe it's not. We need to generate data to set it up. So we Let's go ahead and add that to the project just in case. We'll get rid of it later. So we go back to main. We go and see what is, it's bound to 1. It's that. Okay, so main 256 times 256 times 256 times 4. I think we said that was 64 megabytes. So I can probably declare it here. Let's see, 2 to the 8, 2 to the 8, 2 to the 8. That's 2 to the 24, which is 16 million times 4 bytes. So yeah. So we can just do it and see, even on a 32-bit machine, that's not that much memory. Although we might actually get an error from VC6 if you try to declare too much static data, like above like a gigabyte or something, it complains. So then we're going to run the compute shader. And we'll do it like this. We'll do it in only a limited region of the 256 by 256 by 256. I guess we will have to read back that flag pretty soon, actually. So I probably should have just done it. So we'll do 3 times 64 times 64 times 64. Maybe 32 times 32 times 32. So we'll be drawing a bunch of redundant data until we get the count back. Okay, and so now we need to fill out that array. We need to allocate a buffer for it. So let's do glue int text grid. No, not glue int. uint32. Oh no, glue it. uint32 is text, side textures right here. Text grid. So we now need to allocate text grid. Create shader storage 4 times 64. 26 times 256 times 256. And then we're going to, when we dispatch, bind buffer base 1 comma text grid, and we're going to upload. We're going to use update buffer text grid with at 0 length and size of indices, not indices, text side. What did I call it? Side textures. So then we build grid. Void build grid, void memset side textures 0 size of size. It's 0 ended. We don't need to do that. So we go int x comma y comma z for x equals 0, x less than 64, x for y equals 0, y less than 64 plus y. We say n equals stb rand and 31, where z equals 0, z less than n times 2, z plus equals 2. So let's do some spacing between them again. Side textures of z equals stb rand, or a flag to make sure it's solid. So we'll pick a random texture for each side. Some of them will be black because they're out of the range. A lot of them will be black, actually, which is fine. I just wanted to get something. The textures are indexed ZYX, I'll change that so that Z is the major column. But anyway, file reject. Also, thank you for looking that up. I don't remember if I explicitly. I said it. I know I said it was good to know that it doesn't matter, but thank you for being that resource. Sure, I don't know. I'm sure I've forgotten some step here. Incompatible types in initialization at line 44. This is just a uint thing. Oh. Oh, it's pos. Pos.z, pos.y, pos.x. One or two bit field extract. Wait, bit field extract? How is that? It must be like a parenthesization issue or something. Or does that? No, this gotta be in 430. Let's run it again and see it again. Bit field extract int. Texas uint. I don't understand. What is Texas uint? It's missing the text parameter. Oh, it is, yeah. Oh, right, because this was new code. Yeah. Thank you. I forgot that this was new code. I was sitting there thinking, this is ancient code. Hey, this is running for a long time. Could be a bug. It could just be that this is me initializing the mem set. Oh no, I just took out the mem set. Let's find out where we are. Tools. This is a thing that sucks, is it doesn't come up automatically with the, what is it? View, debug windows, threads. No, it's not under debug windows in this. I forget where threads is in this. Debug threads. It doesn't automatically come up in the right thing. It's hung in link program. That's not great. Is that because it popped up a message box and I didn't see it? I guess I'm hitting a oh, there. Now we hit a bug. Oh, no, it's the same one. Am I rewriting the dispatch inside the loop again? No, that's still if zeroed. Let's make the dispatch smaller. There's no way this takes any amount of time. I wonder why it's making the compiler link slow, assuming that was a real accurate assessment. It's the link step, not the compile step. I assume of a compute shader. Yeah, I have the Meshify compute shader. Why is that slow to link? What could you do that would be slow to link? Yeah, I could, I mean, but I barely changed the shader now, so I'm not sure what part of it would be. I guess that's the point with the shader bug. It could just be these bit field extracts somehow go wrong. Maybe the fact that this is such a huge buffer is causing it to do some analysis to it, and if I just did it like this, it would be better. Yep, that was it. So I just disabled the thing accidentally. So why was that not enough memory? Four times 256 times 256 times 256. That's how big it is. And then when we update it, we use size of side textures. About offset or size. The length. It doesn't have that extra 1,000 that I added. Oh, right, because I added it to the storage, not to the thing. So that's 24. That's 64 megabytes. Oh, it's doing it through the staging buffer. I forgot I had this staging buffer. Yeah, so that won't work. To avoid dealing with these large sizes, I had this. I went through this staging buffer, but I don't need to do that for this particular one. I could just use buffer subdata. I was created with it. It's created so that you have to go through update buffer. Okay, fine. We'll stick to using update buffer. We just have to do it in a loop. For I equals 0, I less than size of, side textures, I plus equals 1024 times 1024, update buffer, text grid, I, 1024 times 1024. Plus I. Plus I over 4. Okay, we kind of got something in the right direction. It's all black as I said it would be. They don't seem to have the different heights. Oh, that's because the heights are much higher than what I'm building, because I brought the dispatch down. So the dispatch is 224, and then each thing was 442. Wasn't I still multiplying by 2, or did I drop the multiplying by 2? Oh, I only multiplied by 2 in the z-axis. Okay, so we bring this back to that. And they're supposed to be random heights. Am I seeing triangles in there? Or is that just... Oh, that's just how they're getting clipped. Okay, let us mask the textures. Since I know I'm just handing in a 5-bit random number, but I only have not quite 3 bits of texture. Let's, in here, go text 1 and equals 7, text 2 and equals 7. Yeah, okay, there we go. So now the heights should be random. Why was it flickering? Oh, because, yes. Yeah, because it's double drawing. It's drawing both faces where they overlap, which is fine, because it should always be internal. So then we can go out to, we can remove the offset by 2, and we say, so what are we doing for build grid? We'll go out to 64, 64, and plus equals 4. So that extends out to about 64 plus a little. So dispatch wants to go up to 64. It's 442, so it is going up to 64. Let's just go higher. So it doesn't seem like they're doing the right STB rand height thing, that they're all different heights. They should all be randomly different heights, unless I'm missing something. Oh, I didn't mask it. I think. Oh, no, I did mask it. Okay. So why are they not all different heights? Is this a GPU side bug or a CPU side bug? Let's change the indexing to XYZ, because I wanted to do that anyway. It's like they're not all loading from a unique slot, or or something's making the data coherent. So I'm missing something again. What am I missing? What am I missing? 2:50. So it's about to be 3 o'clock, which will be 7 hours. What does OBS say? 7 hours. It says we're at 7 hours. Because I started this. No, did I? Oh, did I forget to stop the stream and restart it? No, I did stop the stream and restart it. Didn't I? I must not have, because the timing on this says otherwise. Which is so annoying, because now I have to re-render it to just cut out the preview for the YouTube archive. I guess I could just upload it with the preview to the YouTube archive, because it does have a countdown telling you, so it's easy to skip it. I didn't read my checklist. I made a checklist. I mentioned in past streams I need to make a checklist. I did. What am I missing? Either we're generating the data wrong, or we're... Okay, so let's change how we generate the data. Let's make n be equal to x plus 4. So it should just be a slope. And it's just all wrong. It's just so wrong. What is going on? That chapter stuff doesn't work if you're not a big enough YouTuber, unless they changed that in the last few months. That's the whole thing where you, in the description, you can put a list of timestamps and it turns into markers. Only works for bigger YouTubers. Or at least it did last time I tried it, because I tried doing it and it didn't work. And then I researched why, and that's what they said. Yeah, I don't know why they wouldn't let a small person do it. So text comes from side textures. That's the correct way to index that. What is this doing? I don't see how. Well, unless it is this the logic to decide where to draw it is wrong. Unless this logic is wrong and now we've exposed it. Oh, I'm not drawing the right number of indices. That's why. So the weird patterns we're seeing was due to the weird patterns we're seeing is due to the I don't know how many. Yeah, I gotta read it back. It's still not showing the sloping correctly, but we aren't seeing the weird patterns anymore. Oh no, that is the correct slope because I added 4 to it. Let's just add 1 so it's a little more obvious. But why doesn't it go taller? Oh, because we're not dispatching over a wide enough region, probably. Why are they doubled? Is that wraparound effect again? Oh, slow frame rate because we're drawing way too much garbage. Yeah, why is this got gaps in it? I don't know. because we're not multiplying x and y by anything. What was I supposed to do? Oh, I need to change the dispatch. No, I think I already bumped the dispatch up enough, didn't I? Yeah, the dispatch is going up to 128, and we're not seeing voxels up to 128. Oh, no, that is just right. Oh, it's just being ended with 3 for some reason. I don't know why it's ended with 3 instead of going higher. But that's the effect, at least. Which... I'm ending it with 31, aren't I? Or I'm not ending it with anything anymore. So I'm not quite sure why... So this should go up to 128. Anyway, it seems like it's basically working correctly. There's some finagling here, but because this was just a separate test thing that I wanted to do. This is not the final stuff. So maybe, like, I just wanted to make sure I could do the right thing from the compute shaders. And I think that earlier test actually kind of showed everything I needed to show. Although, I guess if there is a bug in the output buffer thing, it would be good to catch it with this rather than starting to move on and then discover. So back to the dispatch. I dispatched 64. That draws up to 128. The other thing was doing up to 128. Yeah, so this should be getting everything. So why does it stop at 3? Why does it have that repeating pattern at 3? I don't know. I'm not sure what this is doing. How could you, what would make that pattern happen? It's exactly as if this n was being masked by 3. If I add to it, I think the height will just go up. I don't know what z plus equals 2 means. Do I still have that in the shader? Oh, this here. No, yeah, I'm intentionally skipping rows so that I can see the interior. So instead of going z to n, stepping by 1, it's z to n times 2, stepping by 2. It's a perfectly valid question. What could be going wrong? Well, okay, let's put this back in that we had before. Do a slightly different height and see how high it goes, and see if that ridged pattern still happens with this as well. It does. So it's not that the n is somehow getting computed wrong, but somehow the way n gets used, that doesn't make any sense to me. How can that pattern be visible, but at different heights? Like it's like this x is getting masked by 3 right here. It's like somehow it's computing n equals x and 3 plus 1. That is how it's behaving. Let's use y instead and see if it does the exact same thing on y. Like, I don't know how you could mess up the memory and have it do that. Yeah, Y is working correctly. That's what I was supposed to see all along. Why is that not working for X? That's so weird. Because it doesn't seem like it could be something on the compute shader side, because we just saw the compute shader work properly for the Y, and the compute shader doesn't know about this X versus Y stuff. If it can build data up high, it should build the data up high, and this should still be creating data up high. What would be different? What would make X break, but Y not break? The X goes out a lot higher, but we saw we can push it up and down, right? It can't be the storage, because we can push it up and down successfully. Right? It's just showing a slope only of the last 2 bits. It just doesn't make sense. Is it because the STB ran? No, that shouldn't affect it at all, because we're forcing it to always be non-zero. It's the memory aliasing? No, because it's an array of 32-bit numbers. It's a flat array on this side, but of 32-bit numbers. So that it can't be that the indexing is aliasing somehow. And moving it vertically wouldn't make sense. Compiler bug? That's going to take too long. Let's go to source. Let's let it run it and restart it. Let's say Y only goes 0 to 1. Let's say X starts at 4. See what that does. I can't see anything. That's weird. Where did everything go? What? This is just really weird in what it's doing. Does the data need to be mem set? No, it should all be 0 initialized at the start, and we only run it once. Is it only... Yeah, this is behaving really weird. If I don't fill in the first few, it breaks. It's like they're all accessing 0 to 4. That's what it's like they're all accessing 0 to 4, which means right here this number is actually being limited to 65536 times 4, which is because I'm not allocating enough memory to this. Is it not allowed to be that big? So that's how big it is here. But when we create this shear storage buffer, we ask for the same amount plus a tiny bit, but we can back that down. Yeah, it's like it's repeating those first 4 x values. And since it's the high thing, it is like we only have storage for 4 x's. It's like it's this. But yeah, then we tried to upload too much data or something. So then when we update it, we can only it's this. This isn't updating the data. I forgot I split this up. That's what it is. Only the first of these buffers is getting uploaded. Well, no. It's uploading the same buffer for all of them. Yeah, it's re-uploading the exact same buffer that many however many times it's looping. So side textures plus I over 4 was supposed to fix us. That's only if it's flat. If side textures is a flat, that'll do it. I think. What did I change? What I build? Yeah, I changed what I built. Okay. Yeah, so I just got the update buffer logic wrong. Okay, good. Yes. Okay, so it's all working. I'll get the read back for the draw next. I'm gonna take a 5 or 10 minute break. We can talk while I'm taking a break. One millisecond for one chunk. We don't know how long it takes to do the compute shader. Oh, I see. But this is a very dense chunk. Like you wouldn't actually have this many voxels, in a real chunk, and some of that's overhead. Like let's draw it a few times. For I equals 0, I less than 16. Plus 13 times I minus I. So let's see what it costs to run it, 16 of them. It's the problem is still that we're not actually drawing the right number of indices still. So I'm still drawing the dummy guy at the bottom. Now I'm not, because now I'm not drawing enough. Yeah, now I'm not drawing enough. So it's just, can we see the guy at 0, 0? We need to offset. Go x plus equals 1. No, y plus equals 1. No, z plus equals 1. We'll go 1 up so that we can always see the dummy test guy. Okay, we're not drawing the dummy test guy. We are drawing the dummy test guy, and it's slow. So that was, at that we're drawing too much. So 160. No, this is useful to know. 120. Oh, yeah, now it's fast. 125. Well, we don't need to get it exact. We don't have to actually draw exactly every single one. Okay, so now, am I actually drawing all the offset ones? I don't see them. I don't think I'm drawing them. Although it was slow. It was slower than it was before. But I don't see this effect. Oh, I put it on the wrong one. chunk origin 13 times 7 times x, 7 times I, 3 times I. Yep, okay, so now we're drawing 16 instances of it, and it's 8 milliseconds. So let's draw 64 instances of it. I and 15. I and 15. So yeah, it's not a realistic chunk, but it gives us some sense of what we can expect from this GPU. Okay, so yeah, now it's finally tipped over. Because I don't know how much overhead OBS is putting on it, so I want to make the number as big as possible so the overhead is as small as possible. So yeah, at 64 chunks of this size, we're starting to hit issues. But it's super fast with only one chunk. And we'll probably do some kind of LOD for distant chunks, because we'll build this description of the voxels in the GPU. That's the bit field description that we talked about, and then we currently we'll turn those meshes into meshes with 1 voxel per bit. But we could start saying, well, every little 2 by 2 by 2 of voxels, we can voxelize the 2 by 2 into one larger voxel. So we could start doing LODs for a distant stuff, and then that'll have fewer quads, and you could draw further into the distance. Although it'd have to work a little differently, and you only want to do that really when the quads start getting down to 1 by 1, 1 pixel. I mean, does that give you an actual upper limit? You mean, does the test that I just ran tell me what the 980 Ti upper limit is? Yeah, that's fine. That did count as taking a break because I wasn't trying to solve the problems. I was just measuring the system, and that's a different kind of programming. I don't plan on trying to do any occlusion culling. You just you render front to back, and you'll get depth culling at the fragment shading level, but I won't get any geometry culling. I guess I could try using like occlusion queries, but yeah, it's 64 dense chunks, but I don't know how dense these chunks are. I'm only going out to 64 by 64, and they're going to be 256 by 256, but they're dense because they're drawing all the faces. They're not hiding any faces. I just don't have any useful data to know how this fake chunk compares to a real chunk. I literally don't know. Is it 8 times too big or 8 times too small? So there's just no way to know. Does that make sense? I think actually not just going to be a break, it's going to be a lunch break. But I'm not going to take an hour lunch break this time. Try to take a 10-minute lunch break. Let me get food. I'll be right back. Why is my... Oh, I guess my pop-out is frozen. Didn't even notice. Okay, so what's our view count like? Okay, then I think I will. I did not write up my list of audience questions, but let me see if I can think of a question for the audience, since I'm not getting questions. So yesterday I asked how long people have been programming, and I can't remember what the other question I asked was. Are you asking the question, or are you suggesting I ask the question? Okay. Assuming you're a programmer, have you done anything graphics programming, either professionally or hobby or anything like that? That is my question for the audience. And if you're not a programmer, just don't answer. Yeah, and that's a good point. 2D graphics versus 3D graphics. You know, but if you do like UI layout, let's not count that as graphics. I mean, unless you're doing it from art. Like, unless you're taking pieces of art and laying them out. Let's not consider that graphics. Like, I'm kind of curious how many people are watching who are like kind of interested in graphics but have never done it. Is sort of what I'm trying to find out. But I want to hear from everyone to get a sense of what the fraction is. Okay. We do have a couple that are not graphics. And I realize this question it was implied by a lot of these, but do you work in the game industry or not? Just a strict yes or no. Y or N, if you want to be twitchy about it. And if you're an indie game developer, we count that as yes. But if you're a hobbyist not necessarily shipping a game, probably count that as no. Okay, that's good. Now I'm getting a real sense. A lot of people not in the game industry, most people not in the game industry, but most people have done graphics. So Charlotte, that was me taking your suggestion and tweaking it. Because the idea of trying to get a good sense from a lot of disparate answers seemed hard, so the yes-no seems like a more useful way to get a quick sense. I am curious about your version, but it would just take a lot more work to piece together the results. Somebody asked me earlier what my first programming language was, so what's your first programming language? Mine was BASIC. Quake C is a fun answer. Yeah, I saw yesterday we had a lot of people, not a lot, but had a bunch of people who had many years of experience. Some of you may have heard my woes of trying to get my capture setup working before I figured it out. So if you are a programmer, not a general developer, but a programmer, what resolution is the screen on which you primarily do programming? If you're multi-mon, it's the main screen where your editor is going to be. If you know offhand. If you don't know, don't spend time figuring it out. Definitely seems like 1440p is the most popular. 5120 by 2880? Gosh. Like some of those sound more multi-mon than normal, but I can believe they are multi-mon. Yeah, like the ultra wide screen. Did anybody in that list have an aspect ratio that was taller than 16:9? Oh, somebody, I remember somebody had a double vertical resolution. I thought. Yeah, Technic Beam had a double vertical resolution. But yeah, if it's wider than 16:9, like 21:9, don't bother saying it. I just want to hear if anyone has a narrower, taller aspect ratio. Because mine is 2560 by 1600, which is a 1610 rather than a 16:9. And that was the source of my woes of trying to figure out how to stream. So yeah, sounds like 1440p is the most popular. Most people are 16:9, and some people are ultra wide. As promised, I'm done eating. No long lunch break today. Yeah, you can't see the extra space. It's right below the monitor. Why is the top of that? I thought I had dragged this so that it was like that. Weird. Wonder how that got lost. It's two vertical monitors, yeah. Yeah, if you looked on my Blue Sky, I temporarily had set it up so that my second monitor was vertical, was in portrait. Fortunately, I hated how that felt, so I found a different arrangement. Yeah, I did for a long time use, I think it was a 4:3 monitor rotated sideways, so it's through 4. Once it gets to 16:9, that's just too much to tilt into portrait. I feel like that's crazy. But having it be 3:4 was pretty effective. I think it was 1200 by 1600 or something like that. Felt good. I guess maybe if you got used to it, maybe 1016 is okay, but 916 is just getting too tall for me. All right, I'm going to clean up. I'll be right back. Maybe I should ask a question that you guys can answer while I'm gone. What's something else related to all that? Like that one, the resolution is something I asked about because I had that experience. So I'm not going to ask. Do not answer. I'm not going to ask things like what editor do you use, because it's just generic. Everybody has their particular thing. I'm trying to only ask stuff that's like kind of valuable or interesting to me personally. Because who cares? Everybody uses a different editor or whatever. Well, I asked before how many years of experience, which I think is a good enough proxy for that. I can cook crappily stuff, but I just don't bother anymore. It's not worth my effort. What could I ask? I mean, by the time I come up with something to ask, I could have left and come back, probably. Oh, I asked what your first programming language is. So, yeah, what's your preferred programming language? Wow. If you haven't already answered, let me qualify that. If you both program for work and for yourself for hobby or whatever, do the one that's for yourself for hobby. It's your priority. If you only program for work, then you can say what language you use at work, but that's a little less interesting. Okay, let's see what answers we got here. So it's mostly C and C++, and obviously plenty of interesting alternatives from the main candidates. Odin, Zig, Jai. I think I saw one Odin, one Zig, and one two Zigs, two Jais, two Zigs, and one Odin. I think is what I saw. A Rust. Yeah, a couple other outliers like C# Rust. Excuse me. Okay, I think I will get back to work now. So I think my priority is that we use the correct counts from the shader storage buffer, which we can either do by reading back on the CPU, or I can figure out how to do an indirect draw that will get the data, that reads the data with it staying on the GPU the whole time. GL draw elements indirect. So you want to this structure, count, instance count, first index, base vertex, base instance. So we set the bases to 0, we set first index to 0, instance count to 1. No, wait, instance... Wait, where is it getting the... Where is the count of elements? Which one of these is the count of elements? Is count the count of elements? They're defining it relative to this function that I don't know. GL draw elements instanced base vertex base instance. Yeah, okay, count is the number of elements. So what we can do is define this struct where we currently are keeping the mesh thing. We just need a 1, a 0, 0, 0 after it. So we could actually just go ahead and define that struct. Type def struct draw elements indirect command. Uint count, uint instance count, uint first index, uint base vertex, uint base instance. And we define one. DEIC. And then where we initialized it was right here. So we say DEIC dot instance count equals 1, and everything else defaults to 0. And then we can say update buffer mesh count 0 size of DEIC. And just make sure we're still initializing it basically correctly. Yep, okay. Now, I need to add this to SUV platform probably. Draw elements Indirect. I don't think I've ever used it. Yeah. So let's add it. Draw. Where's draw? I should just search for it. GL draw elements. Okay. So it's CPV GL func. When did it get added? 4.0. GL draw elements. That's all it takes to add a function. And then what do we have to map? What do we have to bind that to? GL draw indirect buffer, which I probably don't have here. GL draw indirect buffer. Buffer. Okay. So we go down to here. Draw frame buffers. No, we want other buffers. Where are buffers? GL buffer. We have no GL buffer. What is it? What are the buffers called? GL, like the shader storage buffer. Oh, okay. Ah, yep, buffers. This is GL draw indirect buffer, and it equals 0x8f3f. 0f3f. Yes, okay, good. So now we take, when we go to the draw, of course we'll never know the count if we don't read it back. So we can't learn what the count is. So we will want to read it back, but that's fine for now. So now this becomes GL draw elements indirect, GL quad. What is the type? Oh, that's still GL quads, GL unsigned int. Wait, where do we get the? Oh, I see. Yeah. It still uses the element array buffer. It starts at the offset 0 in the indirect buffer. So now we GL bind buffer, GL indirect buffer, GL draw indirect buffer. And we say whatever that was called, mesh, what was it called? Mesh count is the old one. Yeah, it's okay. It's still called mesh count. Mesh count. And here is where we need to synchronize. We need to make sure that this has been updated by the time we run here, which we won't do to start with as a test. So we comment out the old. What else do I have to change? I don't know. I probably have to change something else. I have a typo in here. Draw elements indirect. That. So that's clearly not the right number. Oh, we need to multiply it by 4. Well, the easiest way to do that, it's kind of dumb, is just going to be to scale it by 4 in the buffer kind of silly. So we atomic add times 4, and we slot divide by 4. It's drawing all of them, and it's not drawing a dummy one. So I think that's correct. Now let's try randomly omitting faces and check that the same thing is still true. Uint face mask. Face count equals bit count face mask. Do I still have that hash in here? Yeah, I do. This is just a hack. I don't care about the fact that it's redundant. Okay, so now they all have randomly some faces missing. It goes all the way up to the top. It stops a little short, but that's because we're not doing the full display mesh. And there is no dummy entries, so yes, I believe this is all working. Looks very solid to me. So now let's put hash mask back to 3, face mask back to 3. And now so I could do a thing where I look at the neighbors and I decide whether the neighbor is occupied or not and eliminate the faces that way. But since this is just an experimental one, this is the real one, I don't think it's even worth doing it that way. I think I just want to move on to the command list processing. So this will be compute shader measure old test2, the poor man's version control system, and now we start working on the real one. And the real one is going to be takes yet another thing, which is the command buffer. Instead of side textures, it's going to take the command buffer. Command buffer uint command list. And we'll continue to do it the same way. We're just going to have every voxel independently compute itself from the command list. So how do we do that? We take our pos, which is our global invocation ID. We're going to, let's put this logic in a function. Uint get mesh offset int face count. So it's that logic. And there's a return in there that we'll have to fix. Okay, these at this point we don't need to explain. That was just me trying to explain how the broadcast works. And then get mesh offset is here. Uint slot equals get mesh offset if base count is greater than 0. Let me do that. Okay, so we're going to be command list processing, and we're just going to do it all in sync. We'll punch this back up to 4x4x4. No, because we're still using this get mesh offset function. Right, okay, so this needs to return. Let's switch this to int instead of uint. And then this can return -1. And this can return int of this. So now slot is an int, and make voxel. Can take an int for this. And so now we're going to step through the command list. And I could declare a bunch of other variables, but I'll let them emerge organically. So what happens is we say int I equals 0. We're going to read out the command list. So int num commands equals command list of I++. There's going to be a super inefficient way of doing this because every voxel is independently reading the command list. They're all in sync in a single work group. But and then so then we go while num commands greater than 0, or I guess 4. I guess we can do this. I guess that's what we want. I think it's cleaner if that's a separate line. I don't like packing that much into the 4. And then in here we parse it. So we say uint header equals command list of I++. And then we say uint type equals bit field extract. That's too many words. Let's just call it header and 3. If type equals, so now we'll have some time to find enums. Time to find command unused is 0. Define command slab is 1. Define command model 3D grid to define command erase 3. So type equals command slab, else if type equals command. Now, these will all be running in lockstep, so we won't be wasting work here processing all of these paths in parallel in this particular scenario. So if the slab, we're only going to implement slabs to start with, we have to parse out the slab data structure, which is in ideas. It's this. So we'll ignore that extra stuff. So we have int z0 equals bit extract int bit extract it might be nice to actually allow these to go negative. The initial coordinates, not the lengths. If we have the bits, and we don't for x and y, because then we wouldn't have to clip in the CPU, but we'll have to clip on the CPU. Oh well. Bit field extract header 4 bits, 12 bits, int zlen equals bit field extract header comma 16 comma 12. Then let's call this data instead of header. Then we load the next piece of data. We get x0 field extract data 0.8. Make x line equals bit field extract. You know what I'm going to do? We're just going to expand this. Oops. Okay, and then uint tech 0 equals command list I++. All right, so now we parse the command, and now we have to process it. So the simple thing is just this. If x0 is less than or equal to pos.x and pos.x is less than x1 and y0 is less than or equal to pos.y and pos.y is less than y1 and z0 is less than or equal to pos.z and pos.z is less than z1. If that happens, then this voxel is in the slab, and we say tech equals tech0. Then when we get down to here, we'll just say base mask equals 7u. 7u. I think that's all it takes to do a quick and dirty version of this. So now we have to try to construct this data. So we need to create a new Wait, was I editing the right one when I was doing all that editing? Yes. Okay. So now we replace the text grid with command list. Doesn't use side textures. The for loop is broken. That is the correct for loop. Thank you. So now it's command list. That was side texture side or side textures or something. Yeah. Text grid was what that was. So now we create shader storage for the command list. And let's just make it 4 megabytes, which is how much we can upload with our staging buffer, if I remember correctly. Yeah, for you shift left 20. So we can update that in one update. We don't need to loop the update and have a bug in that. This is our old voxel build. This is our old voxel build. And it's 8 hours. I was going to try to get more done, but I feel myself getting a little sleepy. So I think I might stop there. But I'm not promising. Don't say bye yet. I'm thinking. If I weren't sleepy, I could definitely keep going. I could do like probably a 10-hour session, but I'm sleepy. Maybe I'm going to push it through it a little bit. Just a little bit, see if I can. But if I get too sleepy, it's going to interfere with my skills. So we create the command list. Right, so we need to put stuff into the command list. And so we make a uint star put command to a command list, uint star p. We'll put a slab. And so the slab will be int x0, int y0, int xz0, int x1, int y1, int z1, uint text 0, uint text 1. And what goes into our thing, p of 0 gets the command slab, which was 1. Let's go ahead and copy those over. Eventually I'll put them in a header file that will get shared by both of them. But command slab or z0 shift left 4, I think it was, or the length shift left 16. P of 1 equals x0, x1 minus x0 shift left 8, y0 shift left 16, y1 minus y0 shift left 24, p of 2 equals text 0, p of 3 equals text 1, and instead of this, let's increment, sorry, p plus plus, return p. Int z1, yeah, thank you. I often do that. If I have two things, I increment the wrong one or increment both sometimes. Okay, so that lets us put a slab in. And so then void build map void uint command data of 1 million entries. That's 4 meg. And we say unit p equals command data. And the first slot in p is the number of things. So we'll come back to that. Int count equals 0. So then at the end, we'll say command data of 0 equals count. And then we'll update the buffer. What did I call it? Build map? I don't remember what I called it. Yeah, build map. So after we've done that, we can upload it. So we say share storage command list. And update the buffer command list. Oh, wait, so we don't need to do this. Update the buffer command list. Starting at 0. The length is p minus command data times size of star p. And it starts at command data. The thing is, I knew that this isn't going to take that much work either, so I wanted to just kind of quickly do it. So we'll just manually update the count. So we say put slab of p. We'll just try to make a box for a 6-walled box of. So it goes from 2 to 2 to 22. 22, no, 2 to 22, and we'll use it's 5-bit at a time, which is annoying. So it's what does 5-bit at a time look like? It's 0x. From the right side, it's 1, 2, 4, 8, and there's 6 of them. So the next one is 0, 1, 2. So I think that's a pattern that if we multiply, that gives us texture 1, and that gives us texture 2, I think. Now the interior we won't be able to see. Oh, we haven't implemented that. Yeah, no, we haven't implemented that. We just implemented the first one. That's fine. So that increments the count. We'll make 4 walls to start with. So the second wall starts in the same spot, but it's 2, 22. And then 222, 22, 2, but we'll have to go to 22, 2. Let's just go ahead and make this readable. Okay. And then we give them different colors. The Meshify needs to see command list. Uh, 27. What was the error? Make voxel face. Oh, it's the previous thing. You went to int 86. Yep. This needs to be an integer so we can down count it. Nothing. Okay, if we set this to text equals 0, 1, 2, 3, 4, 5, 6. Nothing. Face mask equals 7u. Okay, so it's definitely processing all those, and it's just not getting, not hitting. It's never hitting this case, or it's not processing any commands. I haven't successfully uploaded. If I didn't upload the buffer is going to start with 0, and we'll have 0 commands. Okay, so what we'll do is if num commands is 0, then we'll do that thing. And so if we get the big solid block, it means num commands was 0. Pretty sure. Yep, okay. So num commands is 0. Which means we're not correctly uploading. We call build map, right? Yes. We call build map, we increment count, we write count back into command data sub 0, we update command list, starting at position 0, p minus command data. Let's just step in here and see what we're calling update buffer with. Step into update buffer. Length 0. P command data. P points to command data. How is P not getting? Oh, I know why. Didn't copy it out. There you go. Crashed. Infinite loop. Display driver stopped responding and has recovered. No, why is it not resynced? It's working for me. Why is it not resynced back onto the stream? Oh, the projector stopped working. OBS probably broke. Let's stop OBS and restart it. I may have lost my... No, I didn't lose my output to Elgato because we can see that sticking in. You can see my OBS sticking in to my third monitor, but the projection isn't happening. All right, well, let's just try to run it again. Okay, so it just forgot the projector somehow. Oh, I forgot to put black over my stuff when I was doing the whiteboard. Oh, well. Has anybody said anything? Where's my chat gone? Nope, nobody said anything. Okay. So we had an infinite loop. Pretty obvious where that infinite loop would be, so let's just throw a limit on it. It's 256. Let's do int j equals 0. J is less than 256. Let's do 16, just in case, because I don't want to have this happen repeatedly. So let's try again. Okay, good. Okay, so num commands is no longer 0 because we're not displaying this thing. Yeah. If it were 0, that would be showing. So num commands is no longer 0. Oh, we never subtracted num commands. That was what, this was a minus minus I. It needed to be a minus minus num commands. That was the bug. But we'll leave this limiter on just to be on the safe side. Okay, and then we're failing to parse this or something. Command slab should be in the bottom bits, which it is. The Z0 and ZLen start at 4 and 16. 4 and 16. Xlen, Ylen, 0, 8, 16, 24. 0, 8, 16, 24. So that all seems correct. So it seems like we ought to be getting the data out of the command list correctly. If known commands equals 4, right? We expect 4 commands. So let's check that. Yep, we get 4 commands. Sure, so 1, 2, 3, 4, 5, 6. Okay, that didn't make any difference. This should just be what? Clearly, if we set text and face mask, it's pos.x, pos.y, pos.z, x0, y0, z0, x0, x1, y1, z1, z0, z1, x0, x1, y0, y1. One thing that could happen is we'd get out of sync from the command list, but the first one should at least be right. Oh, these need to be 3. It's exclusive. Why are there not more of these? There should be more of these. Two to 22, 2 to 22. And the other axis is 23. There we go. Okay, that's what it was, probably. Nope, dang it. All right, let's put a slab that's super thick somewhere. 2, 2, 2, 22, 22, 22. Nowhere? So why does this not work? Okay, let's pretend we decoded that. X0 equals, what was it again? 2. X0 equals 2. Y0 equals 2. Z0 equals 2. X0, X1 equals 22. Y1 equals 22. Z1 equals 22. Okay, it does work if I manually put it in. Let's limit ourselves to just one command. Let's simplify things. Aha. Yeah, I had a feeling. Let's do this. Why does this not work? Why would this not work? Are we not getting a command slab for our first command? We skip over the first byte. We did not skip over the first byte. That's our first D word. Yep, okay. So now it probably fixed, that was probably the bug the whole time. So let's go flip all the way back without even testing that. And put that back, put that back, put that back. There we go. There it goes. Successful command list processing. The exclusivity has not been set up great, but it's up just typing. So yeah, so I send over 4 commands. The GPU brute forces it. Now let's make the GPU brute force the full 256 by 256 by 512 and see what our performance is like. So actually we'll go up to 1K. So the shader is 4 by 4 by 2. So the dispatch is 4 by 4 by 2, I said. So it's 256 over 4, 256 over 4, 10 by 4 over 2. Okay, and now let's put that in the loop. And see how expensive it is to be calling it every frame. Because this is the super inefficient one, and I was planning on doing all the smarts, but if it's fast, no, it is significant, right? We dropped from 1 millisecond to 14 or 15 milliseconds. So this is definitely a slow way to do it. This is a bad way to do it. Of course, it's potentially producing a lot more voxels than we're seeing because I've only drawn a very small thing, and it actually goes out to, I guess we can pump that up. So let's say it goes from goes from 4 to 240, and we put a slab that goes from X, a Y of 2 to a Y of 140, at a Z of 260, 400, and then that goes out to, wait, X, Y, Z. Oh, I see, I started writing. It's X, Y, Z. So the Z for this slab is at 400, and then it goes to X plus 4, 140, 401, and then the texture is next to 8421. So I'm making a roof that is striped of different colors, and we'll put a gap in it. We'll make it have gaps. And then these 4 now need to go, they start at 4, 2, 1, and they go to 240, 2 or 3 400, and then this one starts at 421 and goes to 5 140 400, and then where we reach the end at 243 400, 2, we then go, go 1, we go to 241 140 400, and then we go from 4 we go from 4 2 1. No, it can't be at 421 again. It has to be 4141. And from there we go to 240 140 400. So it should be much taller. It's very slow because it's got a lot of quads, and I don't see the ceiling. But this obviously has a lot of quads. So let's dump that down to 200. This goes down to 200. Let's change 240 to 120. Okay. Half the size on 2 axes, or 3 axes. Yeah, okay. So now where's the missing ceiling? Oh, we don't increment count. That's why. It's gotten slow again. Why is it so slow? I shouldn't have drawn that many voxels by just adding a top. X plus 3, 2, 140, 200 to 201. That shouldn't be that big. Interesting. Let's just step by 12. Yeah, okay, so now we have this slatted roof. Oh, we've lost the back wall though. Our count is out of sync, probably. Or we overwrote it. I don't know. How would that happen? How did we lose one wall? Unless I zeroed it and didn't notice it. Two to 3, 4 to 5, 120 to 121, 140 to 141. There we go. So there you go. Building out of slabs. And we can make the ground thing show us what the 2v6 by 2v6 should be. So the ground shows us the footprint of the actual chunk. And of course, the chunk ought to be bunch of city blocks, not one giant building. So that just gives us a sense of that. And also, we're not eliminating the interior faces. It's 4:30. Let's eliminate the interior faces. I should probably be able to query. I probably should implement querying to find out how many faces there are, so that we have some idea why it's slow. Because that doesn't seem like there's very much data in that chunk. Oh, it's because I'm still generating it every time. That's why it was slow. There we go. So I can put it back to being big again. So this is 240, 240, 240, 240, 240. Step by 6. And then height is 400, 401, 400, 400, 400. Yeah, okay, great. Yeah, so it was slow because I was still remeshing every time. Okay, there we go. So, like I said, this should actually be a whole ton of buildings, not just this much. So yeah, now I don't need to get the count because now I know the count is legitimately reasonable. It's not going crazy because it's not slow. That was the only reason I wanted to try to read it back. So what was the next step that I was thinking about doing? What's just getting the counter? Oh, it was, I want to eliminate hidden faces. So if we stick our head into these things, we'll see that there are all these interior faces. So let's get rid of those. So the way we do that is each voxel is going to compute a 3 by 3 by 3 occupancy. So shared I guess we can just store it in a uint. Uint neighborhood equals 0. So the neighborhood, so how do we compute this? Basically, we want to compute exactly this, but for the 6 neighbors to know whether they're occupied or not. And we just need to store a single bit for each one, a Boolean for each one. So we could just brute force that. Like, let's just do that. Let's do the brute force way as a quick and dirty thing. 6. And so this is going to be, well, let's not duplicate them all. Let's just do 1. And we're going to call this the neighbor position. Okay, so what we want is 6 booleans. Bool up equals false, down equals false, north equals false, south equals false, west equals false, east equals false. So do we have a neighbor in that direction? We have no neighbors to start with. Then we say npos equals pos plus. Yeah, this is, again, we'd really like these to be signed. I got 3. Okay, so npos equals pos plus ivec 3. Yeah. 1, 0, 0. Let's flatten this out into a single line. And if it's true, then whatever's at the positive x, let's use the same order we've been using elsewhere. So negative is first, and that means let's do that this way too. So px, so nx equals false, positive and negative x, negative y false, positive y, rather than trying to use constructions. False, positive z equals false. Okay. So then we say npos is negative x, and if this test is true, then we set nx equals true. And then we want 6 of these. And all we change is ny. Oh, no, we don't change it to ny, we change it to px. This should be px, ny, py, nz, pz. So now we know if the neighbors exist. So then we can compute the face mask. So the face mask is if both nx and px exist, then face mask loses that bit. If ny and py both exist, then we don't need to draw that face. If nz and pz exist, we don't need to draw this face. If this has an early out, oh right, we returned -1, but we didn't handle that because we didn't actually have that as a case. If slot less than 0, return. And then we pass the face master. I think that's all it takes. I mean, other than me having a bug, obviously. npos, I never declared it. ivec3 npos. Okay, it's like inverted from what it's supposed to be. It only is keeping the internal faces of certain types along certain axes. If you have a neighbor on the x and a neighbor on y, they should be twiddled. Okay, so it looks the same as it did before. Let's go up here and look at the slabs on the top. Yep. And if we stick our heads into the walls, we don't see anything. They're double-sided. We see the interior wall because of the way the thing works. So that does work. We did just call out all the garbage data. And that is where we're going to stop. And of course, should still be, oh no, not in this design. Yeah, right. So that's pretty neat. Yep. All right. I'm done. Let's chat for a little bit. Before we wrap. Let's wrap before we wrap. Sorry. I know that's cringe. How are you still running an older version of Windows? I didn't turn it off. I didn't sell it. It still exists. Okay, I have checked it in. It's uploaded to my NAS. It's all good. That's good progress. We're already... What things did we check off of this list? GPU takes CPU supplied naive conversion of 256 by 256 grid. Command lists, not interesting command lists. Right, naively converts. We had 8 by 8, which means having it iterate internally, I think, which we have not done yet. Okay, so that's, I think, where we are. How come you use VC6? So there's an FAQ below the video. I think it has answers to questions like that. I made it 10 years ago, so I don't exactly remember. I really like that zombies game idea. You mean the city one, or because I talked about the terrain, the outdoor terrain was sort of DayZ inspired, and then there's the city team, the PvE zombie game. If there was any questions that I missed, please re-ask them, but I don't think there were. Let's just go ahead and switch this to Facecam. Yeah, well, so this is I'm re-implementing the city. I'm doing another procedural city, but I don't know what gameplay I'd put behind it. I could go back to that zombie PvE, multiplayer PvE zombie game idea, but I could just do something different. I don't really know. I just really wanted to try this command list GPU rasterization, GPU meshify to rasterization pipeline. Do you use any version control for this stuff? I use a tool called CMirror, mirror as in a reflection, and C as in Casey, because it's Casey Muratori had written it. And it's a simple system that copies your files to a holding place on your local machine, and then synchronizes those up to a server, but just using file I/O, not doing any diffs or anything, and keeps multiple versions on the server. And the basic idea is I have a home directory, like C:Sean, and anything I make goes in there. So there's a project subdirectory, PRJ, under which is a game subdirectory, under which is this CMC2. And when I run it, you can see the directory summary of what it uploaded. And so it doesn't. There's no log message because I'm uploading just anything at all in that tree gets archived. And this was Casey's idea, and it's like the idea is like you're a solo programmer, you don't need to worry about interacting with other programmers. What's the low friction way of making sure you do frequent check-ins? And the low frequency way is no log messages. So it's a little harder or it's a lot harder when you're spelunking old stuff. But it also works just with files. There's no database. There's no anything else. It just puts up files. It renames the files with a version number, a little bit like VMS. What version is this? 1.3D. Yeah, we haven't updated it in a long time. I don't know if Casey still uses it, but I do still use it. It's gotten a little slow for me. One thing we added at some point was when it pulls down the official list of all the files on the server, we added a compression to that so that when that came down over a network, it was a little bit faster. But it's still slow to process that. What is so interesting about voxels? I'm planning on giving it a try. I don't know. I can't tell you. It just is. But yeah, I'm very happy. I mean, it's a nightmare. It's too bad that I spent probably 50% of the time looking for dumb graphics bugs, stuff that validation should catch, stuff that breakpoint that internal validation does catch, but I forgot to set the breakpoint. Maybe I need to find a more robust way to handle that case than relying on VC6 breakpoints. Like you can just hit and I can put in inline assembly and put an int3, int13, int3 I think it is, that will trigger a breakpoint. So I could just force there to be a breakpoint there always. So I don't have to worry about that. And then I want a way to disable it, but I can have a way that disables it only for this execution. Like I overwrite some variable in memory in the debugger. I say, go to this address, reset this variable to 0. Now it'll skip it for the rest of this run, but the next time you run it, it'll be back. Maybe I need to do something like that. In fact, now that I've said it, I'm just going to do it. Message. Static int disable equals 0. If not disable, as in int 3, is that how you do it? It's been a while. Underscore as in. And then I lost it. I accidentally just deleted that curly brace. And then now I want to force it to happen. So let's texture array, array 2D. What is that? 2D array? 2D array. It's 2D array. So one of the ones that I wasn't catching, or that I did catch at some point, was I was trying this. Here it is. It's this one. So I haven't done this in so long. Why is this not trapping? Why is the did I uncomment the wrong line? I uncommented the wrong line. That's why. Yeah, it's not the bind texture. It's the enable. That was what was dying. So I get a breakpoint. But if I try to keep running, I'm going to keep getting that breakpoint. And so what I want to do is take disable, set it to 1. And now when I run, yeah. Yep, that works. Oh, you can't see the code. Sorry. Doesn't matter. I'll just let you see. It's this is what I just added. It's used to just say, it just used to have a dummy assignment that you could breakpoint on. So now it's just automatically breakpoints. So I can keep the same command lists on the CPU, and I probably will bake them down to run lengths on the CPU and collision detect against the run lengths. Or I could bake them down to bit vectors with actual bit per voxel. Yeah, with Casey's version control system, I find that if I ever try to work on 2 machines at the same time, it's just totally broken, because that's not the path that's supposed to work. So, like when I would go home and take my laptop with me versus my desktop, I would sync everything from the desktop, make sure it's 100% synced, download on the desktop, or resync the laptop, so now it has what was on the desktop, and I can't touch the desktop again. Well, as long as I'm doing stuff on the laptop. It's a one person at a time, one machine at a time thing. What do you mean by grid style level design tools? Because the step that we went through was grid based like Ultima Underworlds, and then semi freeform like Doom and Quake, and now you have the modular assets. So I'm not sure which thing you're thinking of with the grid style. If you ever experiment with any non-cube, so when you were talking about Hammer, you were thinking about grid style. Okay, so there is a very specific answer to this. There's a video by Joe Wintergreen, where he or a couple of videos where he talks about this. Let me find one. Well, actually, I don't know that he said he knows why. I think he explains in it why, but I'm not sure in which one he explains why. But he talks about how it's terrible. That so I think the why is just higher quality, because now you get artists making the level assets instead of designers using brushes to create the assets. I think that would be my guess as to what the quick answer is, but let's see if I can find one of his videos about this. No, it's going to be older than that, I guess. I wish I knew what it was called. I'm just skimming through all of his videos looking for one that's about the thing I was talking about. Here we go. Ruminations upon the insidious ubiquity of modular mesh-based level design. So, not saying this is the absolute answer, but here's an answer. Yeah, well, and that's what he talks about. Is that's the drawback is that we've lost the designers getting good iteration by using brush-based tools. I'm not watching that video, so I can't act. It's more than 10 years old, so I don't remember exactly what was said in it. Oops, darn it. Sorry. Oh, you can't see anything because you're in this scene. It doesn't matter. There is a whole plan for using a compute shader to pre-process the render commands on the GPU side to make it more optimized for later GPU steps. And there's a whole plan for a totally different way of building them that's more optimized. There's an FAQ about the Win 7. There's an FAQ below the video, which may have some answers to some of that. The graphics drivers, they appear to just be happy to continue supporting Windows 7 for now. I don't know. I may have hit end of line and forgotten, but I mean, in this particular, actually, that's not true. I'm running a 980 Ti, which I don't know that they're even updating the drivers for that at all anymore. The thing is that Steam and Epic Game Store both no longer support Windows 7. So I've moved my gaming off to a different machine anyway, and this is now only a development machine, not a gaming machine. So all the drivers need to support are my OpenGL usage, not other games. I do not know what Sean McGrath is up to. All right, I think we're going to wrap it up. Have you ever worked at Octrees? Yeah, let me say one thing real quick. I have done stuff with Octrees. The thing that I and many people have found, this is the last question. A friend wants to play multiplayer games, so I'm just going to wrap. The thing I have found and many other people have found is that almost always a 2-level or at most 3-level hierarchy is better. Instead of having a weird recursive algorithm that's messy and slow, you are optimized out on 2 levels. So you have like, imagine that you have a map that's a million units wide. So you have some top level data structure that's 1,000 by 1,000 nodes, and then under each of those nodes is 100 by 100 nodes or whatever it would be, and you just do that, and that lets you be sparse. You can have an empty child node where you need, if sparseness is one of the things you're looking for. The VDB format for voxel data is at least the one that people often use, is a 3-level hierarchy, because they are trying to do such enormous data sets. I can believe that they know what they're doing, and that 3 was the right number for them. But almost always 2. You almost always just want 2 levels, not the infinite octree divisibility. It's just always going to turn out to be faster. The only case where that's not true is if you're making a general purpose tool for other people to use, so you have no idea what kind of content they're going to create for it, then maybe you want to use more flexible data structures like octrees. But they're just going to have more overhead. So that's it. I got to go. So thanks to everybody for showing up. I probably will not stream voxels tomorrow because I did get through a lot of stuff today. But who knows? You never know. But yeah, so thanks for being here. Have fun. See you later.